Welcome to the 2020 Virtual Flow Forum, brought to you by the Water Industry Process Automation and Control Group and supported by International Labmate, the organisers of Water, Wastewater and Environmental Monitoring Conference and Exhibition, and Detectronic Control Systems. My name is Oliver Grievson and I am the Executive Director of WIPAC, as well as the Technical Lead for the Water Industry at Detectronic Control, and I will be your host today. We have three fascinating sessions at this year's Virtual Flow Forum, very much looking at the wastewater side of the industry, and in session one looking at the strategy and standards of flow to full treatment and vent duration monitoring. In session two, looking at monitoring and managing flow in the wastewater system and some of the methods that are new and novel that are helping the water industry to manage the wastewater system, including collection network and treatment. And in the third session, looking at the application of flow measurement technologies that are there, that are coming up, and how we're going to apply them to the water industry. So, hopefully you'll enjoy the Flow Forum. In the first session, I'm going to start the proceedings talking about holistically the water industry. And secondly, we've got Andy Godley of the WRC looking at event duration monitoring. So for the first presentation of today, I'm going to be talking about flow management and measurement in the water industry. Some of the holistic points of view of how we've got to bring the collection system and the wastewater treatment works together. My name is Oliver Grievson, as well as being your host today. I'm the technical lead at Detectronic Control Systems and the executive director at Water Industry Process Automation Control. In my day job, I help a lot of the water companies from everything from flow measurement installations to holistically managing flow measurement systems across the entire asset base. So I'm very much going to give a flavour of what's going on at the minute. The water industry is going through a lot in the UK. We've just started the asset management period. For those of you who don't know, it's our 5-year regulatory period where we deliver a plan that's been presented to the regulator and financed. Wastewater flow and flow compliance is a major part of that plan. There's a lot more monitoring going on at wastewater treatment works, and realistically, and this is something I said at the last Flow Forum 2 years ago, there's very much a direction of bringing the wastewater collection network together with the treatment works, treating them as a wastewater system, and really holistically managing flow across. It's something I'll touch on a bit later. Some things we've got wrong in the past, and I'm as guilty as any because I've worked for a couple of water companies and I've worked for engineering consultants as well. So it's a case of maybe a change of mindset. In the water industry in the UK, the collection network and the wastewater treatment works have been very much two separate things in terms of investment. We're very much going to think of those as one thing, as a wastewater system, and look at the environmental needs that's driving it. And at the minute, over the past couple of weeks, there's been a lot of highlights on the water industry, some a bit unfair. But I'm going to show what the industry is doing now, what it has done over the past few years in the last asset management period, what plans are for the next few years, and some of the challenges the industry faces. Some of those challenges are technological. Some of those are very much business processes and business systems. Some of those are skills-based challenges, and some of those are very much cultural challenges as well. And in those challenges, there's quite a lot of opportunities that the industry can take advantage of. And this is where we start getting into the digital transformation piece. It seems crazy talking about digital transformation when you're talking about flow, but digital transformation is almost a part of everything. And there's a lot going on out there at the minute. And that's going to be very much covered
in some ways in the second session this morning. So, the increasing need to manage flow. There's an argument that we've always needed to manage flow. Years and years ago, dry weather flow, and I'm going to get this definition wrong, but the definition of dry weather flow was very much the flow at the works after 7 days without rain and 7 days of this and 7 days of that, and it made it very difficult to assess what was happening at the wastewater treatment works. That changed in 2005 with an UPWER report where there was a definition of dry weather flow, which is very much around the 20th percentile or Q80, and that helped the industry quite a lot. As a result of that, there was a lot of investment in the industry all around, and this is when MCERTS started. For those of you who aren't aware of MCERTS is a monitoring certification scheme, which basically compels the water companies to measure flow to a certain standard, which is checked by MCERTS inspectors, and it's done a lot for the industry. But arguably in the water industry, quality of the water has always been king. So we've always had BOD, we've always had suspended solids. In the past few decades, we've had ammonia compliance, phosphorus compliance, and everything else. But the actual quantity of flow has been actually very difficult to put a handle on when a works has been compliant and when it hasn't. And more recently, things have been ramping up and ramping up. The past couple of years, we've seen a pollution summit that's been happening in the UK, mainly driven by the fact that serious pollutions, and you can see it in the graph there where my arrow is, serious pollutions have, and really pollutions in general, have been stable. Earlier this year, the water companies in the UK were warned about environmental performance a lot. Then, about 3 weeks ago, we had the sewage and land water bill. You can argue for it, against it. Hopefully, we can use this bill as a way to change things. But of course, that's going to take a lot of money to do it. And then, I don't know if most of you saw it, it was either yesterday or the day before, there was a lot of criticism from groups talking about coastal pollution as well. All of it is all about spills. I mean, that picture in the centre, it's a picture that I've taken in the past. It highlights that's actually the inlet of a wastewater treatment works, but it happens. And sometimes it happens genuinely, and sometimes it doesn't happen genuinely. Sometimes it's a problem. There's several reasons for that. Some of it's been technological, some of it's been design, some of it's actually growth and investment. But now, really within the water industry, certainly in the UK, and I imagine it's either happened or will happen in other countries, quantity compliance is becoming more and more important. And a lot of that is about measurement. So I mentioned the private members bill, the sewage and land water bill. For those of you who have read it, it's really an absolute Christmas tree of this is what we want. One of the things, of course, being who I am, that I picked up was on the need for monitoring. It called for a lot of monitoring. Now, the question is, you could ask, well, do we not monitor? Of course we do, and we have done for years. The photos in front of you, they're probably a bit too small for most people to see, are 10 random works from my sort of gallery of photos that I have, which have got EDMs, flow to full treatment monitoring, flow control, last asset management period, there was a whole program of works. The whole industry worked upon event duration monitoring on CSOs. Why? Well, the monitoring is actually not going to change anything, but the monitoring is going to tell the water industry where the problems are. In the UK especially, the operational model that the UK water companies operate to, there are 10 water and sewage companies, including Welsh Water in Wales, in England and Wales. 11 if you count the company that Severn Trent runs. Somebody will tell me off for pronouncing that wrong, but
about this round offering the advantage
at the end of the day, realistically, the water companies in the UK run a lot of assets. They run tens, if not hundreds of thousands of kilometres of pipe. That's not easy. And in order to do that, we've got to have monitoring. We've got to look at it. Yes, there's monitoring, but actually, there's a whole history of monitoring. We have been monitoring in the past at treatment works, maybe not quite in the right way. A lot of the water companies do a lot of monitoring. So South West Water, for example, I know didn't really have a huge amount to deliver in the last asset management period on event duration monitoring because they'd already done it. So to say that we don't have the monitoring or we need the monitoring is a kind of false analogy because a lot of it already exists. A lot of it needs to be refreshed, of course, as all instrumentation does. But a lot of it exists already. But what have the industry done so far? The answer is a lot. I mentioned the EDM program. There in the top left-hand of the pictures is the ministerial direction. And thank you to Phil Hume because I've nicked most of these slides from him. Phil's an expert in the Environment Agency who did a lot of work on the CSO monitoring the network. And the Environment Agency and the water companies, the last asset management period, delivered thousands of event duration monitors on CSO. They did an amazing job. And I know there are people on this call who were intimately involved in that installation work. What's that given us? Well, bottom right, you can see some of the work that Phil Hume did back in 2016, so a number of years ago, looking at the water company assets on a particular water company and concluding how many CSOs needed investment. That investment is happening this asset management period. I think if I remember correctly, there's about 700 CSOs being invested in this period to improve the environment. The Private Members Bill basically puts that duty on the water companies to improve the environment. But it's work that the companies are already doing, already invested in. The question, I think, probably to the government and to the people is, how quickly do you want us to do that work? It could be done in the next few years, but the cost of rectifying that is extreme. I think somebody did a back packet sort of calculation. And yes, we could solve the pollution crisis. We could do a lot of investment in the wastewater network, but that sort of back packet calculation was about £100 billion, which is twice what the whole industry is going to cost over the next 5 years. So that's a lot of work to be done relatively quick. But there's a lot of work that's already been happening. Ministerial direction, monitoring, a lot of improvement work this asset management period, a lot of improvement work next asset management period. And that's all about getting the data and the information right to enable the investment. Industry's good. Everyone's sorted. Looks like it. So I'll start again there. The industry's already done a lot of work, and it's really to get to the bottom of this, to get to the bottom of the pollution problem. If we were to speak to make everybody happy, the level of investment that's required is extreme, and that's just within the wastewater network, let alone the potential in the future for wastewater treatment works as well. So really, we've got to ask the question, there's a balance here. And some bits looking at a holistic system what are we going to do? And Godley is our next speaker. It's going to talk about UMON 3. And I know these numbers don't mean anything to anyone. UMON 3 is about putting monitors on. This is all about monitoring programs in the next asset management period. UMON 3 is about putting on the StormWIPAC. So for those of you who aren't au fait with the UK water industry, we are very much have storm tanks on a wastewater treatment works. I know that's not the case in other countries. And we have wastewater treatment, which is the flow that wastewater treatment works must treat before going to storm. There's never really been a legal requirement for a monitor to monitor when a treatment works goes to storm and what the pass forward flow is going to the treatment works at that time. That requirement is happening in this asset management period under a program called UMON 3. U is the urban wastewater treatment works, monitoring, monitoring, 3 is just a number. So if you look in the investment program for all of the water companies, there are 2,241 projects across the country. UMON 4, which is measuring the flow to full treatment, that pass forward flow, 1,136. UMON 2 is an investigation project, and that's investigating whether you can use the final effluent monitor that's already in place, already regulated, already quality checked, to imply the flow to full treatment compliance, to imply the pass forward flow. There's 1,104 of those projects, which is a huge amount of work. And the problem with UMON 2 is it's got to be complete by April 2022, ready for investment in the next asset management period. UMON 5 is all about improving the works. UMON 5 is all about increasing the quantity capacity of the treatment works. UMON 6 is all about increasing the amount of storm tanks. That's just the flow control on a wastewater treatment works. So we've got 3,300, 4,000, or in the best part of 5,000 projects across the industry, representing, in my ballpark estimation, somewhere between £1.5 and £2 billion investment. This isn't the only monitoring project within the AMP period. There's another 1,329 projects on a variety of things across the industry. So really, from a monitoring perspective, that's a huge amount of what we are going to do, are planning to do over the next 5 years. And that will inform the way the industry finds out. It's all about, it's not going to solve any problems, but it's going to tell us where the problems are. It's the next step on from the event duration monitoring program that happened in the last AMP. Somebody else will tell me a bit better, but I think there was at least 6,000 or 7,000 projects there. So in a 10-year period, you've got something like 10 or 12,000 monitoring points throughout the network, and a lot of water companies are doing more besides, which is a huge investment to tell us what's going on within the water industry. But there is a dilemma. We've got to control the collection network, we've got to control the wastewater treatment works. And in the past, and absolutely understandably, it's all about being protecting the customer. The top two voters are a bit tongue-in-cheek in some ways, but the risk that if you don't control the collection network is, one is it floods into somebody's house. Ofwat have done a great job this asset management period. There's a lot of punitive fines for water companies through the ODIs that if companies don't control, they will get punitive fines. Or it's the case of, does it go to the environment? Does it go to storm tax? And rightly in the past, it's been very much about, well, we really haven't got anywhere else to put it. We've got a system that's under stress, we've got a combined system. yes, we've got the designs of CSOs to very much act as a pressure relief valve collection network, or we can put it in the storm tank and return it to the process when we can. Not the best way of doing things, but actually it stops this scenario of sewage flooding into somebody's house, sewage flooding into open land. So what do you do? Now, somebody would tell me, well, that's a bit simplistic, and it is a bit simplistic. But of course, the priority of the water companies is always protect customers. We never, as water companies, never want to flood somebody's house. So actually, the storm tank is a good route. For those of you who aren't aware, within the UK, we have something called DG5s, which are customers at risk of internal flooding. And historically, DG5s, what's been the solution? Stick a bigger pump in. SABPI is something I presented the SIWEM Urban Drainage Group at one of their autumn meetings. And again, it is tongue-in-cheek, but it does happen. It did happen in the past. Stick a bigger pump in, transfer the problem to the wastewater treatment works. Because actually, you've got a storm tank that can cope with that. The counter argument to that is, of course, if you stick it in the storm tank and don't return it in time, then the environment is risk. So the dilemma in the past has been very much got to protect customers, got to make sure they don't flood. Where do we put it? Where do we put this sewage? Well, not ideal, but CSO's environment, that's what combined sewer networks is for. If we don't, we can get it to the wastewater treatment works into the storm tank. Now, of course we've got to protect the environment. Of course we do. So sticking a bigger pump in, what's that caused? It's caused overflows to sewage treatment works. Now this installation's got a lot more problems than just that, but what happens when you stick a bigger pump in, the works will control to a certain flow and then it will go over the storm weir. The only way around that is to build a balancing tank to cope with those increased flows. That's more civil, that's more everything. Actually now we've got to look at it more holistically. Can we balance in the wastewater treatment networks to save energy? Can we use the wastewater network as a storm tank? They do in other countries. So Germany has around 50,000 storm tanks in the wastewater network, as an example. The Danish have open ponds. Guess what? Their environmental performance is a lot better. So what I'm trying to say here is we've got to treat the wastewater network not as a network and a treatment works, but in terms of flow management, we've very much got to treat it as one system. Where can we put that water? That sewage? Where is the investment got to go? Combined as a one wastewater system. So a holistic balance. This is a very simplified wastewater treatment works and network. First step to knowing that problem is monitoring. Where do the problems lie? Where's the investment needed? First step is instrumentation. And we've got to balance that, protecting the customer, protecting the aquatic environment, but also protecting the holistic environment as well. And by that, if I go back to 1990, 1995, and the regulations that were set around the formation of the Environment Agency, there was very much a case of treating the air environment, the aquatic environment, and the land environment the same, and balancing across. And that hasn't quite happened. As a nation, we're pushing everything by getting an absolute pristine aquatic environment, but not really thinking from a wastewater perspective much about the air environment, the aquatic environment, and the energy use So we do have to protect, yes, the customer, yes, the environment. We do have to address these pollution issues, but we've got to think properly how we're going to do it. And there's a basically cultural change and a technological challenge and operational challenge in doing that, which is what I'm going to come on to next. In these technological process and operational challenges, there are the standard issues. So I mentioned WWEM 3. There's no published standard for that. Andy Godley's going to cover that in the next presentation. But technologically, how do we make sure that the instrumentation that we have is right for the application? A lot of work's been done on that, but the asset management period has started, and the water companies are moving and installing. And if you look at the right-hand picture, do you install a probe? Do you install a level-based sensor? Big question. Advantages and disadvantages to both. Can you, the UM2, the flow investigations, there's no agreed standard methodology of how to do it. I've got a very good idea of how to do it. Others, I'm sure, have ideas of how to do it. But there's no accepted standard of doing it. If you look at the picture there, on the right-hand side, cantilever arms, level sensor that's not quite level. If you don't get those standards of installation in, then you're going to get bad data. You get bad data, you get bad investment. Because wrong picture, and this is where the first element of digital transformation. Next month I'm going to be talking about instrumentation and digital transformation. So do join me for that. But it's all about having the right instrument in the right place, measuring the right thing, making sure it's measuring correctly. And that enables the first start of what the industry is calling digital transformation. Past has been called Water 4.0. If you don't have the right instrumentation installed in the right way, then immediately you're going to get into trouble. But there's operational management. How do we manage the flow on wastewater treatment works? And this is cultural as well. If you look at the extreme of what's going to happen, storm tanks on wastewater treatment works are used for operational purposes. They're used for balancing flows. Rightly or wrongly, that's not an argument for here. That's the way they are used. Some companies have greater strengths than others. Strictly speaking, it's talking to environment agencies first, agree a methodology of doing it. Everyone will say it doesn't always happen. In the future, when you've got something measuring that storm wind, every single spill to the environment, every spill to that storm tank is going to have to be explained, which is a huge cultural change for operations moving forward. That's a huge change program, huge training program, huge different way of thinking. And that's got to change. There's also data management. The pictures you see there are just a very small extract of some work I did many, many years ago looking at that. How do you trawl through all that data on any particular day, month, week, year, and make sense of that data? How do you see whether a spill to the storm tank was genuine, or whether it was due to a problem or maintenance going on at treatment works? And again, that fits into that culture issue as well. It's that explanation of how every spill to storm tanks is happening, especially if floatable treatment is not being reached. And that's a huge problem. And maybe it's event management. Maybe the solution is event management. Both of these systems are actually clean water. But there are things out there, and we're going to hear about a lot of other things in session 2 that have the potential to look at what's happening within the whole wastewater system, not just treatment works, but the wastewater collection system as well, and tell us what's going on. Takadu have had an event management system for a all around finding out what's happening on the clean water works. It's actually all about data and data management. The other example there is actually an extract from the digital twin in Valencia, the global immune system by Edgar. And that's all about managing flow through the collection network. Is that a solution? Maybe, maybe not. Is that a bit of a hammer to crack a nut? Maybe, maybe not. But how do you justify that? And actually, it can do a lot more. We're going to hear later about a system that allows the water companies to see where there's blockage in the collection network. How can we switch that on its head to manage flows through the wastewater treatment system? How can we find out where there's service capacity, where there's treatment capacity, where there's more flex within the system? But it's also about opportunities as well. And this is where very much the digital transformation piece comes in. Flow measurement management is a major driver. It's designed to help the wastewater system. It will help reduce pollution incidents. It will help us to know what's going on in the wastewater treatment net, wastewater system as a whole. But, and this is a big but, instrumentation has got to be right. Because otherwise, the data that we're getting, the data analytics, very powerful tools. But if you don't get the base instrumentation right from the start of this, then you're starting badly right from the start. And my presentation is frozen. No, that's absolutely complete frozen. So what I was going to say here is there's a huge amount of opportunities. I'll keep on trying to move forward. Huge amount of opportunities for the companies to take advantage. It's finding out, it's that situational awareness within the wastewater treatment network. It's finding out what's going on. Let's see if we can stop presenting. No, it's completely frozen. Everything's, there we go. Huge amount of opportunities. We can use it to detect infiltration. We can use it for pollution reduction. We can use it for justifying investment needs. Now gone too far. We can use it for huge amount, and certainly I've used in the past. If that will go back a bit, I've used it just on a data perspective in the past to see where the infiltration in the network is, to inform teams that are going to go and repair the wastewater treatment network, repair everything that's going on, repair the infiltration points to create more capacity at the wastewater treatment works. So there is those opportunities that can be seen, can be realised. But to do that, we've got to get the right instrumentation installed in the right place, in the right way. And also installed so we can maintain things correctly. So to come back to that, we can use it for energy efficiency, improving the environment, reducing the risks to the customers. There's a lot we can do. Examples there are, one is infiltration, one is pollution. How do we use that data to improve the situation? If I go back 5 years, MCERTS is all about improving the situation, all about working using that data. And we succeeded. How else do we do it? But the challenge, get the instrumentation right from the start, in the right place, right way, right technology, maintained correctly. And with the right systems, we'll have the data that we can use to inform the decisions that we make. So at that, I think I'll ask if there are any questions. Anyone got any questions, comments?
Yep. Hi, Oliver. I put it in the comment as well as Mike. Just I was always going to ask this question. We're focusing on flow and level and quantity of wastewater. Is there anything on the horizon about measuring what's coming out of a CSO as well as how much? Is there any water quality aspect to this at all?
I don't know, to be honest. The EDM program on the CSOs is very much on a risk-based approach. The EDM program doesn't measure quantity. The actual quantity expelled to the environment. So I think probably first would be quantity. But there are solutions, I'm sure somebody will touch on it later. There are solutions that quality could be measured.
Yeah, there's a difference in discharging effectively rainwater to the environment and discharging something that isn't rainwater.
The one thing I will say is the Environment Agency does do a lot of river monitoring. And maybe that's, I don't know, somebody's just saying, worth noting the SOA program covered under
Okay.
SOA program covered under UN will include water quality assessment. So there is.
Okay.
Thank you, Kathy. So yeah, so there will be some aspects, but also bear in mind that the Environment Agency do a lot of quality monitoring anyway. They've got some very smart boats, remote control boats that does do a lot of quality monitoring in rivers. And realistically, do we take that monitoring out to the river environment? And that's a very good question and something, but that's investment.
I was going to say it's a bit late by the time it's got in the river, isn't it?
Yeah, but then we can use that to drive back realistically. I mean, bear in mind, and this is where I think the private members bill was a bit naive. Dare I say an MP was naive, is it didn't include diffuse pollution. It included the point source pollution from wastewater treatment works. And I think, to be honest, environmentally, it was a bit unfair there. Because a lot of the pollution in the rivers are from diffuse sources.
Yeah.
Really? Okay. Yes, you can have a go at the water industry. They're a very easy target to have a go at, and people do have a go. But really, I mean, at the end of the day, you do have to look at the holistic point of view. I mean, if you want to drive treatment standards at wastewater treatment works so low, and the picture I always have in my mind is a crystal clean river and a completely polluted air because the amount of energy it takes.
Yeah.
And there's a balance here, and realistically, have we got that balance right?
I agree.
It's interesting, Oliver. I was actually at a site yesterday, which we were monitoring upstream and downstream of a discharge of a wastewater treatment works. And they're permitted on TSS at 15 milligrams per litre, ammonia, which was pretty low. I think it was less than 1. And I'm not sure what the BOD was. I think it was something like 10 or 15. So we measured before and after, and in the channel coming from the treatment works, the ammonia was 0.1. Okay, so that's their consent. Absolutely great. Their turbidity was running around about 8 to 10, so you might get a 50 to 100% increase in TSS, so it's probably a bit borderline. But the BOD was 11 to 12. Now, based on sort of normal methods of measuring water quality, you would say that was perfectly good discharge, and it clearly wasn't. So it's actually quite fascinating, actually, that you would get the tick for the fact that the ammonia was almost 0 and your TSS was probably in consent. The reality was that the BOD was way over.
But I have a thing about BOD, and
don't we all?
Realistically, that I could have a whole debate on whether BOD is appropriate anymore. I like tryptophan methodologies, which I know you represent. I like TOC, except it's very expensive. I like not so much of a fan of COD, but realistically now I think BOD is a method that is, 110 years old? Really, when we had a 2030 standard, 20 BOD, 30 solid standard, there are some treatment works nowadays that have a BOD consent of 5. And realistically, when you actually look at the method, someone will probably correct me on this, but I think if you don't get more than 2 milligrams of consumption, then the BOD test is invalid anyway.
Yeah, correct.
So realistically, at a consent of 5, you want to measure 10 times lower, i.e. 0.5. You can't measure.
Oliver?
Right.
Just jumping on that. I mean, one of the, in another life, of course, I was involved in instrumentation quite heavily. And I sometimes think now, looking back, some of the instrumentation was actually too good, too complicated, too expensive, and measuring a number which was so costly in terms of time and effort to get it that nobody bothered. So there's a world where we move more to like Boolean indicators that a process is okay. So I was involved in a project many years ago in Mallorca where, unbeknown to me, they had about 100 wastewater treatment plants, all very small, dotted around these tourist installations. And there were lots of complaints from tourists about smells and discharges, and the government took the view that they couldn't put instrumentation on to measure every single thing that could cause a problem. So they just picked suspended solids. And they went round, did an assessment of all the works, and said, when this works is working properly, whatever properly would mean, the suspended solids was between X and Y. And they just used a very, very simple measurement, suspended solids in the final effluent, didn't bother measuring everything else, and they focused their manpower efforts on the ones where something wasn't quite right. So again, if you plug that kind of information now into something like the Takadu system, where it was just doing some AI on a big data set, so when just pick an indicator, and I think then a water company would be more likely to invest in something that gives them some value and some meaning than really expensive, complicated COD, BOD, tryptophan, ammonia. All of those things are a pain in the butt to measure. But if you've got something is better than nothing, particularly if you start doing this holistic approach with a bit of flow, level, water quality, writ large across the network to get an idea of, is the whole thing plus or minus a bit working? We've got more chance of doing it. It's about making measurements affordable from a TOTEX point of view and meaningful from a reliability point of view for me, rather than picking on some arcane measurement that you almost need a PhD to get.
Yeah.
Anyway, that's my comment.
It's interesting. It really is interesting as to what we do. But there's a lot that can be done, and we're going to hear a lot in session 2. But yeah, at the end of the day, the challenge for the industry in wastewater, I think, really now, put our hands up. It's about controlling that flow within the wastewater system. No longer should we talk about network and treatments, and make sure you know what's going on. I don't know really. It's difficult. It's very difficult as to what's going to happen. But from the industry point of view, we can all see what's going to be the direction going forward.
Our second speaker today is Andy Godley, who is a senior consultant for flow measurement and metering at the WRC. Andy has over 30 years' experience in all aspects of flow measurement and metering in clean and wastewater applications. He manages a number of WRC's flow testing facilities and has carried out many research programs so understands the technical capabilities of many types of flow measurement equipment. He's been closely involved with the development of various aspects of the Environment Agency's monitoring certification scheme, and specifically the various flow schemes over a number of years. He's going to talk about the development of guidelines for the installation and operation of EDMs for FFT compliance. Basically, what's going to tell us when a wastewater treatment work goes to storm. Andy, I'll let you take over.
So a slightly wordy title there. Development of guidelines for installation and operation of EDMs for flow to full treatment compliance assessment. Hopefully, why it's so wordy will become clear as we go through. For those of you that don't know me, I'm Andy Godley. I'm Senior Consultant at Water Research Centre for flow measurement metering. And I've been working I work across both clean water and wastewater, but with a very sort of specific remit around flow. And I've been working on MCERTS, as Oliver said, the monitoring certification scheme that the Environment Agency have for flow measurement for quite a number of years. And in many ways, this is the sort of next stage in the MCERTS program. And sort of I'll explain how that goes in as we go along. So a little bit of background and a bit of summary of some of the work that's been happening to date. As Oliver says, this sort of stems from the asset management plans that the UK water industry worked to, the 5-year plans. So some of the preparation for this was done in the last AMP, and it's now coming to fruition in this AMP. So I'll give you a bit of background to summarise that, and how the sort of schemes in relation to sort of event duration monitoring for flow to full treatment compliance might work, and documents that we've been working with the Environment Agency to prepare, particularly this document around minimum installation standards, and some of the complexities that have had to feed into that. So Oliver's already mentioned UMON 3, UMON 4 drivers. So these are in the Water Industry National Environment Programme, the WINEP programme. So this is a programme that was agreed between the UK Environment Agency, or England and Wales, English Environment Agency, and the UK water companies, that sort of defines the actions that water companies will need to complete to meet their environmental obligations. And within that, there's a number of drivers and a number of programs, and Oliver sort of mentioned some of them. The focus really for the EDM work is this UMON 3 driver, where there is a desire to fit EDMs onto treatment work, overflows, or storm management systems. So effectively the last in line overflow before the influent enters the treatment works, which is often on the inlet channel where the treatment works, but it may be upstream at a pumping station as well. And the point of that is to then be able to check that the discharge isn't going to storm prematurely, and that the works is treating the amount of influent that it's supposed to treat. And so that can be sort of simplistically viewed like this. It's quite a sort of simple case. So on the left-hand axis there, you've got flow. Along the bottom, you've got a sort of a time series. So your flow obviously goes up and down. Every works will have a permitted flow that it has to treat, which is represented by the green line. So the flow will sometimes go over that line and spill to storm, and sometimes not. And the red sort of line indicates our event duration monitor. So we can see that in the first case, the flow to treatment is going sort of slightly above its permitted level, even allowing for the measurement uncertainty within that flow measurement. And the EDM activates when that happens, and that is correct, because the flow is, works is treating what it's supposed to treat, and it's only spilling when the flow exceeds that value. Whereas you can see on the right-hand case, that non-compliant works, if the permitted value was slightly higher, then even allowing for measurement uncertainty in the flow measurement, that works is spilling early, so it's non-compliant with its permit. I mean, that's a very simplistic case. In reality, flows are a lot more complicated. They go up and down. There's a lot more spikes, but that's a sort of simplistic view of what we're trying to achieve. And as Oliver said, so this preparatory work for this goes back to the sort of a number of years. The derivation of those drivers, the WINEP program. There was a UK WER report, 2017, which was produced by Servolec with input from Critical Flow Systems, that looked at some of the challenges around this. Wastewater treatment works, flow to full treatment, how you do that sort of monitoring and assessment. Quite a weighty report. We were asked, as WRC were asked in sort of beginning of 2019, to sort of take that and sort of look at how, do a sort of fairly overview, brief report on how event duration monitors in practice could be used for that compliance assessment, and some of the pitfalls with that, and how that could possibly fit in with the MCERTS scheme and the various standards in the MCERTS scheme. From that, we then produced an initial guidance document, because one of the output from that, really the conclusion from that initial review was, yes, we can do this. It could be fitted in with a sort of similar scheme that's analogous to the self-monitoring of flow scheme. It could be fitted to MCERTS, but there was need for further guidance. There was need for some clear standards and development of documentation to support that, such that users and the inspectors and the whole community, the whole stakeholder group knew what was required. And there was particular concern around installation and operation of event duration monitors. And so earlier this year, we produced for the Environment Agency an initial draft document, guidance for use of event duration monitors, which covered installation and some of those other issues. And also sitting alongside that, a draft product standard. So one of the for those of you who don't know MCERTS, I will try to explain that a little bit more later on. But effectively, we have equipment standards that are intended to ensure that equipment can be tested and certified and demonstrated as fit for purpose. So the MCERTS product standard. Those two documents were put out for consultation, and there was we had a big workshop on the 29th of April earlier this year, with a lot of stakeholders involved: water companies, regulators, suppliers, consultants, MCERTS inspectors, the whole community. It was quite a challenge. That was early on in lockdown, and we were all working online, and it was quite an interesting experience. But we had about 50 people at that workshop, say from the whole stakeholder community, and we went through the documents in some detail. And recently, sort of since that, we've been working with the agency to refine the documents, and in particular, the one in blue there, what started out as the sort of guidance for use of event duration monitors has now ended up with this quite wordy title, MCERTS Minimum Installation Standards for the Self-Monitoring of Discharge Events for the Purpose of FFT Compliance. I think the agency were very keen to make this very clear that this suite of documents, this is around the use of event duration monitors for FFT compliance. So it's nothing to do with the EDMs that are used for CSOs and further up in the wastewater network. This is purely around the application of these devices for, say, the last spill before it enters the treatment works. So we've got a revised document which takes into account a lot of the input from the workshop and the other comments that were received, and that we were hoping to have really sort of got that finalised by now. But there are still discussions that the agency are having through the squidgy group and through the flow task and finish group to further refine that. And the agency now have started working on an MCERTS self-monitoring standard for EDM, so something very similar to the self-monitoring of flow document that sort of sets out their requirements. And ultimately, I think a lot of the information in the minimum installation standards document that we've produced will feed into that self-monitoring standard. So for those of you that are sort of not necessarily familiar with how all these things hang together, treatment works in the UK operate under a permit system that's sort of set by the Environment Agency that defines how they should operate, their environmental regulations, their obligations rather, limits on the quality of the discharge, quantity of discharge, and all the sort of parameters around actually protecting the environment in relation to the sort of discharges that might come out of the treatment works. So the operating permit is really the key document for every works, and then MCERTS monitoring certification scheme is effectively how that permit, certain aspects of that permit are sort of regulated and policed and monitored. And MCERTS itself, particularly in relation to the sort of water schemes, there's also MCERTS for air emission monitoring as well, but we're focusing here on MCERTS for water, has sort of two key elements, one of which sort of mentioned is a product certification scheme. So this is to make sure that products, sensors, equipment, flow meters, EDMs that are used for monitoring environmental discharges are fit for purpose, are fully capable of doing that job to the standards that are required by the agency. And the other part of it is really around how water companies operate and how they monitor and report these discharges. So the hexagons there in blue are, what a water company does. It has to, down to the water company to obtain the equipment, and obviously the equipment is equipment that's been through the product certification scheme, ideally, has to select that equipment, has to install it properly, has to operate it properly, has to make sure they have all the processes involved for data handling, data management that meet their permit requirements. So all those are the activities that the water company does. They're all required to be incorporated within a quality management system, QMS, and that itself is, under the self-monitoring scheme, is audited by independent auditors. So that whole QMS scheme is audited. But there's also a physical inspection of what's happening at the site. So this is where the MCERTS inspectors come in to make sure that the equipment that's being used is appropriate, that it's installed correctly, that's being operated correctly, so that it meets those measurement requirements that the agency have put in place. The document we've produced for the EDMs around the installation standards is, while it focuses very much on the installation aspects, it also touches on things like equipment selection, it touches on site inspection, and it touches on operation as well. So there's a number of things at the moment that are bound up in that. And that's sort of quite deliberate at the moment, because the sort of input from the water companies, from the inspectors and from the other stakeholders was around sort of seeing how this might work as a totality, all the different aspects sort of pulled together into one place. But ultimately, as I say, some of that will go across to product certification, and some of that will go across into the site inspection scheme and the self-monitoring standards. But at the moment, we have this document that tries to pull all those different aspects together. So when we started work for the agency on this, there were a number of key objectives for us. One was to provide a common understanding. So this document will provide a common understanding between regulators, users, inspectors, auditors, contractors, all the stakeholders groups, really, so that everyone had looking at the same document, singing from the same hymn sheet, to use the well-known cliche, and had that common understanding. Within that, obviously, we wanted to encompass good practice. The ultimate is to, as I said earlier, is just to make sure that those permit conditions can be met. and we want that to be done in such a way that the measurements are robust, they're valid. So there's all the aspects around good practice for instrument selection, installation, and everything all feed into that, as Oliver highlighted in his earlier presentation. It had to be practical and pragmatic. So, in line with other MCERT standards, this is not gold plating. This is trying to produce something that actually is workable by water companies, by others, and also that it recognises and accommodates a wide range of practice that's already in place. And we'll talk about a little bit about that shortly. As I said earlier this year, we had the stakeholder workshop that sort of discussed the first draft document that we produced. One of the key criticisms that came through strongly from the water companies was that there were a lot of aspects in that were far too prescriptive, and really it should be down to the water companies to manage some of those aspects so that they could manage the risks in relation to the data and their sort of permit compliance. So when we revised the document, it was very much with that feedback in mind. So the revised document had an initial objective to sort of enable the water companies to manage risks, and hopefully I'll explain how that has been achieved as we go through. So going on to some of the complexities and some of the difficulties we had to sort of try and accommodate. So there's lots of different types of instrumentation that can be used for EDMs. And they seem to fall into two main camps, which we've labelled Type A and Type B. So you have a sort of the EDM system where effectively you've got a continuous level measurement. It can be an ultrasonic, it can be a pressure sensor, a radar sensor, but it's basically providing you a continuous measurement of the water level within the channel or tank or whatever you're looking at. So that's the Type A sensor, is that continuous level measurement. Or you've got the other type, the Type B, which effectively is a switch, a level switch type input. So a sensor that is located in a certain place, and that when the water level hits that place, usually sort of in relation to the height of a discharge weir, for example, when the water level hits that position, it provides an alarm output or a status change that indicates a discharge is occurring. We're also aware that there are some types which sort of hybridize these two types, so perhaps work as a switch point, which continuous level sensor then switches in. But again, we can accommodate those within the documentation, we think. The other piece of one that came in really after the consultation was that where there are rising mains, particularly this is the case with pumping stations, so the last in line, where storm excess flow may be pumped directly to a storm tank from the wet well, for example. There we found instances of people having flow meters in those lines and using the output from the flow meter to detect the start and stop of a discharge flow. And again, we've tried to incorporate that within the document. There are a number of difficulties with that, but it is an alternative approach, which we've tried to encompass. And as I said, sort of, EDMs can be located in lots of different places. So commonly it's on the inlet channel of a treatment works, either as a single side weir or even as a double side weir, for example. We have come across cases where there are, on the works inlet, there may be a big holding tank, balancing tank, or a wet well type situation, where there will be a bell mouth type overflow. So the tank will gradually fill, and when it hits that discharge point, then it will flow down through the bell mouth and out through a storm tank. Or the one on the right there is a sort of typical wet well type thing where, normally the duty pump is pumping from the inflows into the treatment works, but the storm pump will kick in pump to storm either on a certain rate of rise or on when the water level hits a critical point in a wet well. And there are various other permutations and combinations on this as well that we had to try and accommodate. And there is a bit of guidance in the document around some of the pros and cons of those different systems. So it's split up into the sort of gravity type systems where you've got a weir or an overflow, and the pumped systems where you have a wet well and a tank. And there are a number of pros and cons of different sort of locations where you can put the EDM in each of those. So you can put it before the discharge. If you've got a gravity system, then you've got a calm surface close upstream. That's probably going to be the best place to put it. If you try and put it on the weir, then potentially more susceptible to fouling and ragging, and short-term spikes. Could be false alarms, could be genuine discharge. If you try and put it in the discharge channel after the weir, we visited one site where there was a very large, it was a side weir, a double side weir, with a very large channel afterwards, and there was a level sensor mounted above the discharge channel, which was great, and that was supposed to detect when water started flowing in the discharge channel. But there was standing water in this channel, and plants had begun to grow in it, so you sort of wonder how accurate that would be at actually detecting a discharge in that channel. And obviously, in that case, then there's a high maintenance overhead in terms of keeping that channel free from weed growth, debris, and so on. So we're not saying it can't be used, but what we're trying to point out is that there may be implications of trying to do it there. If it's the only place to do it, then that's fine. But again, it goes back to this thing that we're not saying it's one way or the other. The water company has to manage that risk. If they're happy cleaning that channel out once a week to get rid of the standing water and weed growth, then that's fine. That's their decision. And similarly with pump systems, there's good places and bad places to put them. If you've got a tank or a wet well, then perhaps you have an independent level sensor as your EDM. But that needs to be consistent with the pump controls, so in which case, why not actually use the pump controls? Because then that as soon as that pump is operating, then the discharge is being put to waste. Okay, there's a little bit of maybe a little bit of timing there around line filling and drain time, but that can be accounted for. If the flow meter option, we don't recommend that at all in a horizontal pipe or a sloping pipe, because you've got the fill time. But in a vertical pipe, then that could be possible, as long as the flow meter will respond sufficiently quickly when flow starts up. So again, we're not saying there's one way or another. We're saying there's lots of different ways, but there might be pros and cons of some of those different locations. One of the other complexities is EDM, we try to split it into a number of elements. So at some point within any EDM system, there's a sensor, whether it be a type A or a type B, that's responding to a water level. That's linked to some electronics. And then there'll be a signal from that electronics, which will either go to a data logger or a telemetry. And that ultimately will go to the water company systems for sort of storage processing. And there's a number of points in that chain where an overflow status signal may be generated. We're not saying it should be generated at any particular location, but it may be a local alarm, within the electronics of the sensor may show that. It may happen within processing within the local data logger or telemetry interface there, or it may happen at the remote off-site at the sort of data acquisition SCADA end, where, particularly if you've got a level sensor that's providing a level measurement, and that level measurement is transmitted through the system, and then the data system at the end point says, is this level higher or lower than my threshold value, my overflow level, and then put the alarm in there. So again, there's a number of options there. one thing the installation standards document doesn't really touch on too much is how that data handling aspect should be covered. It provides some requirements around what is required from data, but it doesn't any talk at all about how that is handled and managed within the water company. We're very much focused on the front end. The product standard, again, is focused predominantly on the EDM itself and its associated electronics. If that incorporates a data logger, I'm not saying it should, but if it does, then we've got some requirements around the data logging capability in there as well. So that was some of the complexity that we had to deal with when we were developing this minimum installation standards document. And as I said, it really tries to pull everything together into one place. So almost all you need to know about EDMs. And I'm not going to continue to repeat the phrase for FFT compliance, but you can take it that the ... sort of refers to that. Now, the scope of this is very much focused on new and replacement EDMs that are being fitted for under this AMP. So the Environment Agency has said that they're not going to require water companies to rip up existing equipment, provided that it is fit for purpose and doing an adequate job. So very much focus on installing new equipment. And as I said earlier, it does incorporate elements currently which will form part of a quality management system, and it also incorporates elements that are sort of implicit or explicit requirements for some of the products, which will then feed through into the product certification scheme. And the box on the right shows you what's sort of covered within that within the document, and the sections now in response to the sort of feedback from the first document, particularly around, it's up to the water companies to balance the risk. We've divided the sections, tried to divide the sections quite clearly into what are requirements, i.e. what shall be done, and we've tried to keep the requirements to a minimum, and then supporting that with further guidance, as in, well, this is one way that you might consider how to meet those requirements. And some of the sections, for example, like power, the requirement section is actually very short. It just sort of says that there should be a robust and power supply to the instrument that ensures that the data availability that's within the permit requirements can be met. And then the further guidance gives you more sort of information around how that might be achieved. So we've tried to keep it quite separate and make the requirements very clear and what is guidance very clear in response to the initial consultation. And I've got some examples coming up of how that has been done. So, for example, and I apologise that this presentation is quite wordy, but I haven't got many pictures for these at the moment. But what we've tried to do, so for example, in the selection section of an EDM, so it's up to the operator to select the EDM that is most appropriate for their operations and for the site of the discharge, but they shall select the most appropriate instrument. So that's a key requirement. The performance requirement, the EDM shall be able to detect when the water level reaches or falls below the overflow level within plus or minus 5 millimeters. There's a very clear performance requirement in there. We did get quite a lot of discussion around what that performance requirement shall be. There was a lot of thought that it should be relaxed to 10 millimeters. There were some suppliers saying, well, we can do a lot better than that. We can do 2 millimeters. We can do 1 millimeter. So trying to balance those needs. And one of the things that we were trying to do, even though this document is very much focused on FFT and doesn't cover CSO type EDMs, there is a very good document that was produced by WWEM around EDMs for CSO monitoring, and that includes a performance requirement or requirement for 5 millimeters. So we thought, well, there's consistency there, and we've tried to incorporate that consistency in a number of places. But it seemed like if that was good enough for a CSO, then that should be possible on a treatment works or on a last discharge before the works situation. A response time. We haven't said what a response time should be, but what we've tried to say is that the response time of an EDM shall take account of the likely changes in water level at that site. Some sites obviously have different inputs, which can change very rapidly, pumped inputs in particular. Some where they've got a gravity upstream can be more gradual. But it's up to the operator to make sure that they pick an instrument with an appropriate response time for that. So some of the guidance documents part of that section then is very much relaxed in terms of things like, well, it's a good idea if you have an instrument that's IP65, for example. This is going to be in a wet environment. Fine, if the water company wants to put in something that's less robust and change it once a week or every time it rains, then that is purely down to their decision and their processes. And similarly with hazardous areas, some water companies define in sewers as hazardous areas, some don't, and there's sort of a bit of a grey area across some of those. So it's very much, these are things to think about. They're not saying you must do this, but they are things that should be taken into account when you select the EDM. Oh. I've got all of this problem now. I'm freezing. Try that. There we are. The document is primarily, as I say, focused on installation and commissioning, particularly installation of the EDM. And so the section on requirements for installation is much longer than perhaps the select other sections, because that was seen as one of the primary focuses for the document. And again, there's such a lot of variation on site. It's very difficult to be explicit, but the EDM should be positioned to record the entire duration of a discharge as accurately as possible. That's very important. And we'll look at what that means in a moment. One of the other requirements, the agency are very keen that if an agency officer arrives on site, that they can see the discharge status in some way, shape or form. That could be through a display on the EDM itself, or it might be through another type of indicator. A requirement that came through in the latest version, so that if you've got a level sensor device, you remember we had the picture of all the different stages of the EDM. If the post-processing is carried out at the SCADA end, at the central systems at the water company, so all you can see at the site is a reading of the level, then there must be information on the site that says what the trigger point for a discharge is. So that the officer can look at the discharge and say, well, its water level is 500 millimeters at the moment. The discharge is set at 550, and therefore it's not discharging. It's not discharging. Tick the box, and everything's hunky dory. So very, very clear that. So we've got that full picture to the officer on the site. The permit conditions require sort of all spills to be monitored and reported. So again, when the instrument is set up, it shouldn't be smoothing or averaging the level readings. But what we're trying to avoid is very short-term spikes. So the SIWEM document talks about persistence. So again, we've taken the lead from that and got a sort of a 1 second value in there, so that to remove just very, very short-term spikes that might be caused by, I don't know, an electrical switch or something that sort of happens in the background, which has nothing to do with the EDM or the flow in the channel. So putting that into some sort of context, so the orange line shows us our level reading. So this is what you might get from a Type A sensor. The blue line shows us our status from a Type B EDM, sort of a simple on-off, 1 or 0. And you can see that the level in this channel is rising gradually. Something happens at that point around sort of just after around about 10:05, 22:05, something happens, and we get a little spike there. Now that may be something like a return kicking in. So we've got the flow in the channel is increasing because of the storm. A return kicks in that pushes that just over the discharge limit. And as the flow increases, and you may get a few waves, you may get other discharges coming in. And then in sort of period B, there obviously we've got a fairly steady storm situation happening there. Flow dropping down. Period C, we've got another spike. So even though perhaps the inflow has dropped, we get another return or something coming into the channel, which is causing another sort of short-term discharge. And then after that period D, everything's back to sort of calm and happy again. So what the agency is saying is that they would expect to see in that trace, they would expect to see all of those short-term discharges in section A reported, section B reported as a sort of a longer-term discharge, and that short section in C reported again as a short discharge. So they get a complete picture of what's happening in that in that situation. But obviously, a lot of short-term, very short spills can, in time, add up to quite a significant amount of influent going over into the storm tank, which ultimately presents a risk to the environment. I said also that this document touches on the inspection and maintenance. So, the intention is that the EDMs come under the self-monitoring scheme and are assessed by an independent MCERTS inspector every 5 years in a very similar way to the flow measurement arrangements currently are. And the inspector has to check the EDM has been installed correctly, that it's working correctly, and that it's meeting the performance requirements that have been set. And in terms of the sort of maintenance aspects, in that section, the requirement is for the operators to have their quality management system in place to ensure that maintenance is done appropriately. It has been, for those of you who have been involved in the flow scheme, maintenance has been a bit of an issue that we've been trying to tackle. We don't say, how often or what sort of maintenance it is, but the blue box there is the guidance, sort of, so that it gives some sort of guidance in terms of what would be expected from a maintenance regime within the QMS. Touching again on sort of some of the telemetry side of things, fairly simple requirements around making sure that it's robust and that the data that can be produced is sufficient to meet the permit conditions that are in the permit for completeness and availability of data. 2 minute, the discharge status or water level should be recorded at 2 minute intervals. That's quite a specific requirement, or as specified in the permit, if different. And then there's guidance around how that might be met. So, for example, in terms of ensuring that completeness of data can be met, then it might be advisable, particularly on a remote site with dodgy telemetry, to incorporate a local data logger so that any gaps caused by dropouts in telemetry can then be backfilled, for example, and making sure that the radio links, if it's a radio or cellular telephone link, that you've got good signal strength there to maintain that consistent data transfer. So we're not telling companies how to do this. We're just sort of putting some points there that are useful guidance in terms of, these are some of the things that you might want to consider. So that's sort of a brief introduction to that minimum installation standards document. It's grown from 10 pages to sort of 20 odd pages. It's quite a substantial document, so there's not really time here to go through it all. But as I say, it is currently with the squidgy group and the task and finish group to be signed off, or any final amendments to be made. I just want to also touch on here the product standard. So for those of you that are in the supply chain, there will be a product standard for certification of EDMs as fit for purpose. So very much modelled on other MCERTS standards, particularly the flow meter standard, including requirements for sort of basic performance, influence of electrical conditions, influence of environmental conditions. And then say there is an option if data logging is incorporated within the EDM system that's being certified, then there's some requirements and some tests around the logging capability there. This document is a draft at the moment, partly because the installation standards document has, as I say, some implicit requirements for the thing. So until that's been signed off, then we can't really finalise the product standard. Once that's been finalised, once the installation document, guidance document has been finalised, then those sort of implicit requirements can be made sure we've got them consistent in the product standard. So that will be happening fairly soon. So just to summarise then, the intention is that the environment, and I sort of repeat, I don't speak for the Environment Agency here at all. I'm purely speaking for the work that we've done by WRC under this. But our understanding is that EDMs for FFT compliant will come under MCERTS with a very similar self-monitoring approach to the current flow scheme. We've revised the document that was produced early this year, and we now have the minimum installation standards document that is going through, say, formal processes, the Environment Agency consultative groups with the water industry, Squidgy and the Flow Task and Finish group. It is broader than just installation, deliberately so. So it does incorporate things that you might expect to see in a quality management system and a product standard. But at the moment, that is quite deliberate. They may be separated out at some point in the future. And we've tried hard to separate out the requirements, the minimum requirements, and then further guidance, and make it very clear what is requirements and what are guidance. The draft product standards, as I just said, is being finalised, and the agency are working on sort of the next stage, which is to incorporate this into a formal self-monitoring standard for EDMs, which I think is anticipated early next year. So that's it. That's where we are. I guess if anyone has any questions on that, as I say, I can only speak from a WRC point of view, not from a Environment Agency point of view. But if anyone has any questions, then please ask.
I've got a quick question for you, Andy. First of all, hello. Nice to meet you again in this virtual world. Really interesting like that. And again, it fits in very well with a smart wastewater type approach, which we were again hearing about yesterday at the Swan Forum. When you talk about the requirements and certification, if this was to be a cloud-based solution, for example, which may or may not be acceptable, is there anything in those standards about the cloud bits and data security and encryption and all that, or is the document going to stop with the flow meter and the data logger, or how are you going to have you thought about the fact that some proposed solutions, particularly given some of these things might be remote and no power, could be battery powered and completely cloud based? Any thoughts on that?
Yes, it has been something that has been considered. It was raised by early on by supply chain. In the minimum installation standards document at the moment, there is reference to security and encryption. I'm trying to think how that's been carried through into the product standard, whether that's one of the things that we've got to take on. But yes, it doesn't preclude any technical solution. We've tried to be as technology transparent as we can, and recognizing that remote, a lot of these things are on very remote sites, and that there are lots of different ways of getting information from A to B. different places to store information. So yeah, security is definitely highlighted somewhere.
Okay, thank you, Andy.
So there's a question in the chat, Andy. And you mentioned that UMON 3 installed before the standard will not be required to be reinstalled as long as it is fit for purpose. Is there any indication of how this will be assessed, proved?
I think it will be, my understanding is that the wording at the moment is, I'll find the exact wording because I'll get it right. Where is it? In the scope. It's basically provided that it's I'm trying to find the wording now. Similar to how it's in the flow scheme. If an MCERTS inspector deems that it is fit for purpose, then yes, it will be acceptable. And by fit for purpose, it effectively meets the requirements of the standard.
Okay, so it would still have to comply with the 5 mil, etc., type thing.
That's my current understanding.
Yeah. I hope that answers the question. Any more questions, comments? We've got about 5 or 6 minutes, so we've got time for a few more questions. Any more sort of general questions about where the industry are? I see this as an opportunity. I saw a number of years ago the ministerial direction on EDMs. Good or bad, I think it's done a great job. I think the water company's done a great job putting all those EDMs in. I see MCERTS over the years. A lot of people have criticised it. But I think it's provided a lot of great value as well. Yes, the investment's been relatively large, and I see this almost as the next step. So it's why I think about it very holistically. It is the next step. We've got problems that any wastewater system is going to have, and it's our chance to collect that data and then turn it into something a lot more interesting, to help with infiltration, to help with everything else. I'll always remember a scheme years ago that I was convinced there was infiltration because of the data, and that avoided investment, or avoided the majority of the investment on the treatment works, because we found the infiltration into the system, and then infiltration reduction created the capacity. So that kind of helps with investment as well.
Just can I jump in there? Just on the timing question. You talked about this going to happen in this AMP, or so. If there are water company people on here, and I know Catherine is from Thames, for example, are you waiting for this standard to become issued rather than be a draft until you start to implement these solutions? Or are you going to be implementing them ahead of the issuing of this guidance from the WRC?
I'll just answer from Thames Water's perspective. We have found it very difficult to, we are concerned about the successful delivery of year one of UMON 3 due to the delay in this standard, and especially following the confirmation that anything installed prior to this point must meet that standard. So potentially is going to have to be ripped out and something else installed. So it is quite concerning. The kind of the developments. We are obviously fitting what we believe is fit for purpose and what we can. I think we are going to need to take away this latest draft to ensure to see what that means for our delivery. You know, obviously our intention is to deliver to the best of our ability, but we are in November now and we have to install everything by March, which is obviously a little bit tricky. So we are going to be taking that away to figure out how we can make this work and what that means.
And I think that's echoed across a lot of companies. There was a meeting recently, and that concern was echoed. It's a lot of work. I think in my presentation, it's available on LinkedIn, etc. I highlighted 2,500 schemes on UMON 3. That's a lot. Realistically, it's probably more. There's a lot of work to be done out there.
Oliver, just jump in if you don't mind.
Yeah,
and Mark's away 720. I see one of the biggest challenges with this is after it's been installed, is actually collating, analysing, and then reporting all the data. Because if you think about the amount of alarms this is going to potentially generate, there's going to be a vast amount of time taken up looking at all this data and report. And I suspect that when the regulators get the reports through, they're going to have the same challenges in terms of resources and looking at the data themselves. So that's where I see some of the difficulties from a water company perspective. And in a way, it's also a bit of an incentive for us to get rid of some of the noise because we suspect that identifying the actual storm events from things like these little alarms, as Andy pointed out in one of the graphs there, that are generated by maybe process issues or maintenance issues. They're the ones we need to get rid of, in a sense, and then get to a point where we're actually producing genuine storm events. But in the meantime, it's going to be a whole lot of work looking at this data that's coming through, especially with the requirement being the 2 minutes interval data log.
Mark, I couldn't have actually paid you to make that comment better because, of course, our next presentation after the break is dealing with the noise by Dave Walker. So,
oh yeah, I didn't know that.
I think in our next session you will see some of the solutions starting to come through to help water companies dealing with that data. I certainly have had quite a few chats with quite a few people about that because I see the data management, and especially from an operational perspective, the site data management. So, for example, electronic notes for sites saying, well, I use the storm tank for this purpose, and here is the evidence from the agency permission, etc., etc., etc. That sort of management system of the data and of the events. And yes, you can probably do that relatively manually, but I think holistically helping the water company in that objective has got to be something where an intelligent system-based person can really help the industry quite a lot.
Yeah, definitely. We're going to get all this data coming through, and it's basically going to be who's going to look at it and where's the time going to come from to analyse it. So anything we can do to work smarter in this area. Yeah. Hopefully Dave will be able to give us a few pointers in that. So I'll go and grab a coffee and get ready for that next presentation.
My next session is this next session is all about that with Detectronic, Siemens and StormHarvester all presenting sort of some solutions from different aspects. But I think that, to be honest, I think it's actually something probably for the Ofwat Innovation Fund, a collaboration coming together and working with the water companies, say, this is what we need. And I don't see it as a major, it needs development, but I don't see it as a major barrier. But yes, the data management is a concern. Alistair, I don't know if you're still on the call. The other presentations, it will be very much upon the individual speakers. I can bring them together, speak and bring them together. I have had control over my presentation, but it's up to the others if they want to share.
In our second session of This Is Forum, we're very much talking about managing the wastewater system, and we've got three speakers who are going to talk about various different aspects. The first is Dave Walker, who's going to be talking about dealing with the noise, electromagnetic noise, and how that affects our measurements. Second is Darren Meaning and Stephen Howes from Siemens, who's going to talk about the MindSphere system and the prevention of pollution events and improved regulatory compliance by using a system-based intelligence. And lastly, Brian Moloney of StormHarvester, who's going to talk about intelligent sewers and how we can make alarms smarter. Our first speaker in this session is the Reverend Dave Walker of Detectronic. He's actually worked in the flow survey industry for over 30 years, with experience of operating flow surveys in the UK and realistically globally. His work has been wide-ranging, from permanent flow measurement within the Mersey Estuary Pollution Alleviation Programme to short and long-term flow surveys in urban and rural drainage area catchments and sustainable urban drainage systems. Dave studied at Sheffield Hallam University, where his work focused on sewer flow measurement instrumentation and practices.
Okay, well, thank you very much, Oliver, for inviting me to talk and everybody else. The talk, as it states there, is dealing with the noise. I've got a couple of ground rules that have been given first from Oliver. Knowing that I'm a commercial director, I've got the first ground rule, that is no selling, no talking about Detectronic and our brilliant instruments and levels and flow monitors and the service we provide to the UK and global water industry. So I can't talk about that. And the second one is he knows that I'm a vicar priest in the Church of England, so I can't turn this into a sermon and I can't preach the good news of the kingdom to anybody either. So they're the two ground rules out of the way. So, and moving on from that, though, is one thing about sermons is I've always been told that keep it to about 15 minutes. So the slides are going to be, I reckon, I haven't practiced this, done a rerun, trial run, but we're around about 15 minutes. And then hoping that will actually open up a number of questions for discussion for all of us. Okay. So we'll start with this first slide. Dealing with noise, it took me back when I was putting this paper together, is been around about 5 years old in the 1970s. I don't know if anybody recognises this, but this is a TV screen from a cathode ray tube in the 1970s. Anybody remember back in those days? The young ones obviously won't, but they weren't probably around. But back in the 1970s, we were blessed with having 3 TV channels. And those 3 TV channels weren't always on. And when they weren't broadcasting, this is what you get. It was what's called white noise. And white noise is a raster of just noise moving up and down on the back of the screen. What was interesting to me right at the early age of 5, and excuse me for talking about my childhood and how exciting I must have been, but I'd sit and watch that raster. I'd watch that 1970s TV set, and then every time my mum had come close with a vacuum cleaner, the raster would change and get more vibrant. And then when she'd move the vacuum cleaner away from the TV set, it's a change again. And I'm thinking, wow, the vacuum cleaner's talking to the television. Well, that's effectively what noise is about. It's about, and when I'm talking about noise, I'm talking about electrical noise, electrical interference. Well, noise actually is talking and being received, in that case, by the actual TV set. Couple of pieces of legislation, and I'm not going to bore us with this, but it's good to know that the Electromagnetic Compatibility Directive, otherwise known, abbreviated as EMC, that actually controls how we design and manufacture and deploy instrumentation, electronic instrumentation into the wide world. And there's various tests we have to do there to, one, make sure it doesn't radiate electrical noise, and also that it doesn't actually receive electrical noise. Now, as strong as those regulations are, and there's been a lot of work over many years to develop that directive and the testing behind it, we do still have problems with noise being emitted and transmitted and received on a lot of our instrumentation. And whether that's an instrument in EDM monitoring, it could be in a sewer monitor, instrumentation on a wastewater treatment plant or pump station, there's always a lot of noise floating around. And I'm going to just touch on that and the principles behind that. The low voltage directive, again, is another directive what we have to comply with when considering how to design and manufacture instrumentation for the field. And I said I weren't going to delve onto that because that will take us a lot of time talking about legislation. But this is what I want to talk about at this moment is sources of noise. I'm not talking about the drums or the trombones and the musical noise. We're talking about interference and electrical noise from various other radiating sources. Pylon, for instance, those very large pylons can give up to 110 kilovolts of electricity. You only have to stand under one of those pylons, and when it's a damp weather like we are today throughout the UK, and you'll hear that electricity crackling as it's actually connecting to the water, to the atmosphere, to the damp atmosphere. So there's so much electrical radiation from pylons and electrical transmission sources. One on the right down there is AM transmitters. So this is amplitude modulation. You can also have frequency transmitters, which is radio stations, etc. I first came across this in Canada. Well, actually, no, it was in Australia first, and then it happened in Canada as well. We installed a Detectronic flow meter many years ago, 30 years ago. And every time we'd calibrate the level would just drift. And we just wouldn't understand it. It'd come back for calibration. We'd go on site and calibrate it, but the level would drift. I got to this particular wastewater treatment plant in Australia, and the perimeter fence of the treatment plant, metal fence, I put an oscilloscope on, attached it to the fence. And every time the person on the radio was singing, you could see the electrical noise change on the actual fence. The actual noise itself had a peak value of 2.5 volts peak to peak. You could light a small light bulb up with it. That's how much noise was being radiated. Just behind the trees at that treatment plant, there's a row of dense trees, was a radio transmitter. And that's what was happening, radio transmitter, transmitting the noise onto the perimeter fence coming and bringing that noise to our instrument. And in this case, it was bringing it back up through the earth supply. So it wasn't even radiating onto the actual instrument itself. On that, we have advanced over the years, and I'll touch on how we now eliminate some of that noise. But earth, having a good earth supply or a poor earth, as I've just explained there, can also create problems. So if you've got an environment, rural environment, and a very poor earth supply, but you've got noise penetrating around the area, it's very likely if you've got a mains powered piece of equipment, you could have noise coming back up through that earth and actually affecting, could be if it's a level transmitter or a velocity transmitter, it could actually be affecting that. So we have to be appreciative of earth supplies when dealing with EDMs and mains powered equipment. Portable equipment, battery operated, tends to overcome that because you're not connecting to earth, so it's isolated from the earth itself. It's what's called double insulated as well, so we not have the same problem there. The one on the left, motors, switchgear, can also give us big problems when you've got high voltage switching. that can actually just hit any power line, and you just get a spike coming through. And the thing is, with instrumentation, we're dealing with very low signals, and then we amplify them up. An amplifier in its nature will amplify the signal. If you've got noise coming into the first stage of that first 3-stage amplifier, then you're actually going to be amplifying the noise and not the actual true signal you want. So we've got to look at ways of eliminating that. And now EMC regulations actually work towards that, but are not foolproof by any means. So particularly installation where we can, you've got a great big power pump at the left-hand side there, the white box there, switch gear with a solenoid at the bottom. When that solenoid kicks in, that actually gives out quite a lot of EMF, electrical and mechanical force, and can actually be picked up on instrumentation. Interesting in this case, it's not actually the instrument side of it, it's the actual earth supply, what's transmitting that noise down to the receive circuit, and then the receive circuit amplifying the actual noise as it transmits that high power voltage, that peak, when that solenoid kicks in and out. And it only happens every now and again. The other thing what we have to be careful with is CPUs are very susceptible to noise and switchgear. To an extent, they can actually just crash. So we, again, have to be careful where we're actually mounting equipment, even though we've gone through a number of EMC tests, etc., to shield our equipment. And that's what I'm going to just talk on the next slide, is how to reduce or filter out that noise. Yes, we can do it in electronics. So we can actually use what's called low pass filters or high pass filters. So that's frequencies. If we've got a mains source, a 240 volt or a 415 volt mains supply, what's causing you problems? Well, that's going to be transmitting at a frequency of around about 50 to 60 hertz, not kilohertz, but hertz. So you'd want a high pass filter, i.e. you're going to block out that 50 hertz, and then you pass forward any high frequencies. So that's basic electronics. And as any manufacturer for manufacturing level velocity flow monitoring equipment, that's not something new to these guys. That's what we do in the background anyway. We can also purchase low pass and high pass filters as well to put onto the actual main supply themselves. So that's another way of reducing it. As again, I'm showing the earth bar there. It's extremely important to make sure that you've got an adequate earth supply. And that might be, if you're actually in a rural area, driving in, not just one earth spike, but you may need up to 4 earth spikes. There's a lot of research done on earth bonding. And if anybody's experiencing problems with noise on instrumentation, mains powered instrumentation, then there's a lot of research being done on how to actually make sure you've got a decent earth bond. There's been a change in switchgear over the past 15, 20 years to make it more efficient. And what that has, there's been a knock-on effect of making the switchgear more efficient, is we get high voltage spikes when it actually switches on and off, or it actually changes its phase. So the earth supplies now have got to be much more robust than they ever were previously. Bottom left of that screen, we've got what's called a beaded core, a screened core. So you've got your cables in there, and you've got this beaded screen wrapped around that. Now, that's great. And what we have to do as electronic engineers is, as long as we put that screen to earth, that's going to create a Faraday cage around them core signal cables and protect them. Now, something what does tend to happen on a braided screen and connecting it to earth, if you're not experienced in earthing and screening of applications, you get this effect where everybody says, make sure you've screened it, make sure you put the screen to earth, and they screen both ends. Well, when you screen both ends of a cable to earth, you've effectively created yourself a very good antenna. And so you're not screening no more. What you're now doing is inducing and introducing more susceptible applications for receiving radio transmissions. You only have to read up about Marconi and what he did all them years ago. He made some fantastic antennas. And got to be careful that you don't end up screening both ends. So that is one of the other factors what we do tend to find in the field. If people are saying, "Oh, we've done all the earthing, we've done all the screening, and we've still got noise bouncing around our permanent EDM monitors, etc." Now, that what I've just talked about is electrical interference and how to overcome it and how to identify it. What I'm just going to touch on now for the latter 5 minutes of the talk is noisy data and what causes noisy data. Effectively, what causes noisy data is product limitations, is not understanding what the actual range of the product is for various applications. As I mentioned, as manufacturers, instrumentation manufacturers, we're all aware how to do EMC and how to reduce all that and what to look out for switchgear, etc., and telecoms. But this is actually now down to the users and the people that are actually taking the instrumentation and deploying it into their networks. So this is from a particular live site in the UK, one of the UK water companies. I'm not going to name which one it is. And this is noisy data, as you can see it. That dark blue line in the center there is actual true data. All this is what we call noise. And again, I reiterate, not electrical noise. This is where we've got, it's an ultrasonic level sensor, and I'm going to go on to that in a bit. It's where we're losing echo and it's giving wrong data. So this is incorrect data. The only way at this point now to get rid of that information is to have some clever tools within your software programs to actually start eliminating and actually effectively erasing them noisy spikes. So you're manipulating data. And that's what's been having to be done in many EDM monitors throughout the UK. Not all, but many. And certainly anybody from the UK water industry responsible for EDM monitors, I'm sure, and I'm not a betting man, but I bet you a few pounds here that they've seen data like that. That particular application is shown here as a schematic. The actual distance from the actual ultrasonic sensor to the invert is actually 2,550 millimeters. Well, this is a 3 meter range ultrasonic level sensor. So it's within range, but it is towards its level, to its maximum range. When we say 3 meters, we're only within 500 millimeters, if that, of the actual range of that sensor. It should still work. But if you look down on the left-hand side, flow install, and this is the installation sheet on this particular site, it was turbulent. Now that's what's also causing and creating problems and giving us that particular data. And as I said, that particular data is from this particular site. And there you can see it. I think that's quite anonymous. We're not telling any tales here, but sensor slightly offset from the center of the invert. So you got potential of bouncing off an uneven surface of the actual channel itself. Turbulence, as I mentioned. Now, you can overcome that turbulence if you've got all that energy coming back to the ultrasonic sensor. So what you need to do there is actually mount the ultrasonic sensor much closer to the target of measurement, and that will actually give all that energy coming back and not be affected as much by turbulence of the actual flow itself. The limitation on that I'll touch on in a bit is because there's a deadband on an ultrasonic sensor, and the rate of rise could actually go into the deadband, and I'll touch on that in a bit. Wind and air movement, not majorly a problem in sewer networks, but when you've got a very large open channel, ultrasonic sensors are used extensively for monitoring the speed of air and wind movement. And those air movement sensors are transmitting and receiving at the exact same frequency, as so happens, as the ultrasonic level sensors we use in our sewer network. So yes, wind and air movement can actually have an adverse effect on the signal being received. Temperature, I'll touch on that in a bit as well, is a big issue with ultrasonic sensors. Now, that's something we all know a lot about. So we've got some very clever algorithms and signal processing to overcome that. But I will touch on temperature as well. And again, finally, distance from sensor to invert, you're near on its maximum range in this particular application. Hence the reason why that photograph you can see there, and that installation is giving that data. So 4 limitations of ultrasonic level sensors, as I mentioned, 200 to 300 mil deadband. So by mounting the actual sensor in the, I'm going to run through this quick because Alistair McKinnon's coming on and he knows all about ultrasonic level sensors. So 200, 300 millimeter deadband is a typical deadband of where any water going into that deadband, then the sensor is what we call blind. We have improved, and when I say we, the instrumentation manufacturers of ultrasonic level sensors are improving that deadband and the angle of spread, beam spread, which is at the bottom now. 1 in 5 beam spread typically. So at 3 meter range, you're looking at 600 mil beam spread. Again, we are improving the angle and the beam spreads, but let's stick here with the traditional ultrasonic level sensors. Wind speed, as I've just mentioned, 40 to 200 kilohertz is the ultrasonic sensors used for wind speed. So in large open environments where you've got wind passing through that beam, then that will also create noise and interference on that ultrasonic sensor. And the final one on that slide is surface foaming, fogs, etc., fats, oils and grease. They have a tendency to absorb the ultrasound and the energy. What we need is that energy hitting the actual target of measurement and returning back to the ultrasonic sensor in one go. And the only real way to do that is, well, 2 ways, is either increase the power, which can cause a couple of problems because you've got, if it's a battery operated system, then you've got limitations on power and longevity of life before changing the batteries. But also, if you increase the power too much, you have what's called ringing effect. And I've got a slide showing the ringing effect in a bit. So you can't increase it too much. The other way is to actually lower the sensor much closer to the target measurement, so you're getting all the energy focused and returning back to the ultrasonic sensor itself. But again, the limitation of placing an ultrasonic close to the target of measurement is that deadband. At once the water, there's a surcharge conditions, and it goes into that deadband, then the ultrasonic sensor is blind. Temperature, I just touched on it slightly there, but you can see here that just a 5 degrees change in temperature. The table on the right is an 8 meter transmission. So at 8 meters, you've got a 75 millimeter error in the target measurement. Same error associated with 5 degrees centigrade on the left if you're within 800 millimeters of measurement. As you can see there, the actual error in level reading is much less. Now, temperature is something we all are well aware of, and we do some very clever adjustments within the circuitry within out the ultrasonic sensors out there in the market. But when you're at such a distance of 8 meters, if you're monitoring the temperature in close proximity to the actual ultrasonic sensor, to actually know the actual change in temperature throughout that column of air, i.e. 8 meters length of column of air, then you need to know what the changes are, or that will also give you inaccuracies. So again, actually, if that ultrasonic level sensor, and I keep using ultrasonic level sensor because it's a fantastic tool in sewer network monitoring, EDM, it's non-contact. It's non-contact, so it can be brought very close to the target of measurement and actually not interfere with the actual flow itself. So ultrasonic signal, echoes, we can have. So here, what we're showing here on the right is the ringing, which is that big, large area at the beginning of that plot, and then you've got multiple echoes. Now you'd think and like to appreciate that this larger echo down here is your true signal, but it isn't. The large echo is here at the start. And you've now got to develop algorithms to actually say, is it this small echo here? Is it this echo here? Or is it this very little one down here? What's the true echo? Now, in a laboratory, in our test rigs, we know which echo it is because we're there and we're seeing it. Out on site, that instrument is relying on the clever technology and the algorithms behind that to actually interpret that graph, that data plot there. So that's what we're up against. And I'm not saying that we don't do that, because some of the ultrasonic level manufacturers on here have been doing this for years, as well as Detectronic. So we've learned a lot about that and how to process that. But if those echoes change and they vary because of any noise or whether that's turbulence or anything like that, that's what gives us that. I'm just going to quickly run back to it. That particular plot there, that is what we will get when we don't understand that interpretation. Okay, so things what we have to look out for, which are pretty standard and straightforward in a chamber: channel benching and pipe radius, what may actually refract the energy coming back from the sensor. Step irons in the way, mechanical, electrical screens, as I mentioned earlier on about electrical noise, turbulence, surface foam, loss of echo, air movement, if it's a large open channel. Loose access covers. Yeah, we're dealing with noise here. So you've got a loose access cover and it creates a big bang. Then what's that going to do to our sensors in the sewer network? So mounting ultrasonic level sensor in close proximity to the target of measurement. We've got a comparison graph there. The red line is the traditional ultrasonic red sensor, and the blue line is where we've actually mounted the sensor in close proximity to the target of measurement. As you can see there on the level, the ultrasonic level is actually below the spillway at that point, but within close proximity. The advantage of what we got there is what Andy Godley touched on earlier in his talk as well, is actually we're still able to pick up that valuable data in dry weather conditions. We can pick up the diurnal patterns, and the information, what we can gain from that, can actually help us in helping with the forecasting and the algorithms and the fuzzy logics and all that data analysis, what has to go post-processing. So the closer we can mount our ultrasonic level sensor to target of measurement, keeping it focused, getting that energy back is the way to go. And you can see that as the comparison of the data there on the right-hand side. The red data is the traditional ultrasonic level sensor with that spiking, as we saw earlier on, that noise. If you've got that red data, you've got to try and pre-process that and actually try and get rid of all that noise and that background, what's just distracting from the true reading. So, final slide, summing up. Check your environment for sources of transmission, EMC, frequency and voltage. In fact, I've got an app on my phone. It's an EMC tester. It's a free app, so you get a shed load of adverts about what to buy your wife for Christmas or a partner for Christmas. As long as you get over that bit, it's pretty good. I walk under a pylon and you can see it go off at scale. So it's a good app. What we also do within Detectronic is we carry a portable oscilloscope, and that also allows us to actually pick up noise and any interference, what we might be receiving from electrical background noises, etc. And at the bottom, check the application. Is the product suitable and is it in range for what you're wanting to achieve? Okay, if it's just a on-off, you might get away with it. But if you want that reliable data, that background data, make sure that you're within range. Okay.
Our next speakers are Darren Meaning and Stephen Howes from Siemens, who are going to talk about the prevention of pollution events and improved regulatory compliance. And the way they're going to look at this is by using the intelligence that's already within the sensor data asset base that we have within the water industry, putting that into MindSphere, a Siemens product, into the applications that within MindSphere to help the industry to develop methodologies of using data and information in intelligent ways.
So, good afternoon, everyone. My name is Darren Meaning. I'm the sales specialist for Siemens, and my colleague will be joining me later. That's Stephen Howes. Will give a demonstration. And as you can see there, the presentation is on prevention of pollution events and improved regulatory compliance. So if I may just start with some scene setting and just cover some of the industry requirements. So this is a very simplified schematic of a treatment works. And as you can see on the discharge side for 10 years now, we've been asked to implement MCERT flow meters to monitor total daily volumes, monitoring flows at greater than 50 meters cubed per day, 15-minute intervals, and uncertainty of better than 8%. So, that's hopefully all pretty familiar. And of course, what we've started to see in more recent years is population growth, housing development, climate change, more extreme weather events, and those things have all put greater demands, obviously, on those sewage treatment works. So there's been a driver, certainly on the operational side, to implement applications that will help manage that load. And Siemens have developed things like SIVA blockage predictor that identifies blockages in CSOs in the sewer network itself, and SIVA Pump Guardian, which identifies and prevents blockages within pumps, and SIVA Sewer, which is essentially modeling your sewer network and through optimization of pumps and valves regulating your flow going into your treatment works. So on the operational side of things, seems to have had things covered, but as I say, in recent years, things have changed. So with the implementation of UMON 3, we've seen event duration monitoring taking place. Quite stringent accuracy requirements, as Mr. Godley was mentioning, sort of 5 millimeter accuracy to, I think it's still 2-minute intervals. And data loggers for a minimum of 60 days, and just back up that data for 6 years. So quite a big change from where we were with just simple MCERTS monitoring. Potentially also looking at the storm retention tanks. How much capacity do they have in those storm retention tanks? And also, as has been mentioned, the flow to full treatment or pass forward flow, you're monitoring the minimum permitted flow rate before you're allowed to spill to a storm tank. And as Andy was saying, that's potentially at spilling to storm tanks, but also at the last inline discharge point. So just before it goes into a watercourse or a river or something like that. So the regulatory compliance side of things, as the burden on the water companies has increased significantly, and as I think Mark Swain was suggesting, that's it's going to be very difficult, we believe, for a lot of the water companies to manage. And so we believe now there's an opportunity for another app from Siemens, and we've called that MCERTS. And it's very much in its infancy, very much just looking to canvas what the industry is looking for, and hopefully deliver an app that meets the industry's needs. So to say we have done that canvassing. We've looked at the operational drivers for regulatory compliance, and what we're seeing is that there's no quick and simple visualization of compliance. What the status of that compliance is at any one point in time. Quite often, the end user is unaware of pollution incidents pending. It might be quite nice to have a time to spill alarm, if you like, so that there's potential for somebody to do something about it. And they're unable, therefore, to react quickly to any pending non-compliance. So there's a few things that, for us to work on there in terms of giving notice to people of a pending non-compliance. And in terms of, again, operational side of things, just a frustration that we often wasted time visiting sites, which had effectively false positives. Got to site, it wasn't spilling, it was a bit of rag or something over the sensor, giving that false positive. Some concerns over lack of data security in this new cybersecurity world that we are taking part in. And also, particularly on the MCERTS auditing side of things, just gathering that data for that audit report was often quite time-consuming, having to fill in missed data reports, and just try to. Our idea is, if you like, is to bring all of that together and bring the reporting together, as I think Oliver was saying, that we could have some running commentary as time goes on. So we don't leave it right to the end to bring it together, so we can put in the notices from the Environment Agency to say why there was a spill. Was it a power outage? Was the pump down, or whatever the issues might be, that we can attach those reasons for non-compliance at the time, rather than wait to the auditing at the end. So if that sounds quite expensive, what we're trying to do, well, hopefully it's not. We've got a number of what we call smart instruments. In other words, instruments that have got inbuilt communications already on board. So there's some examples of some here, and I'm sure most water companies will be familiar with some of these. So, it's ultrasonic level sensors, ultrasonic level transmitters and controllers. We've got some very low cost but highly accurate radar transmitters there, as well as things like mag meters. And although our mag meters don't necessarily come with comms as standard, there's a comms module that's easily retrofitted to the transmitter. So it's not a case of taking out an old complete new meter and replacing it with a new one. It is a very easy retrofit, as I say. So we can use those smart instruments to give us far more diagnostic information as well as process variable, and we can transfer that information through a gateway, something like the CC240, which you may have seen my colleague Steve Howes doing some presentations on LinkedIn recently. That allows us to get all of that data into a cloud-based platform where we can do far more with it. And it's about having that then real-time visibility of your asset status, and being able to present that in a nice, easy format to give you that instantaneous understanding of what is happening within that treatment works, and also, of course, simplified reporting at the end. so that you can satisfy the EA's requirements. So that sounds nice, and it isn't that far from being reality, I suspect, for a lot of companies. But it's also just understanding a bit more about what's happening. So demonstrating compliance and understanding the reasons for non-compliance, that's what is really of interest, I suppose. So this is a very simplified graph. So please excuse its simplicity. Andy Godley's probably pulling holes in it already, but so the flow to full treatment line is very simplified. There's no dashes, as you saw on Andy's slide, which show 8% either side. I've simplified it just to make it nice and easy to understand. But if we show the flow to full treatment, we can see that on the first sort of graph, the flow sort of plateaus, and you can see there that the eventuation monitoring, what EDM sensors kicked in. So we're showing a spill for the duration of the FFT being reached. So fairly simple, easy to understand. And most people, I think, would look at that and go, yeah, no problem. That looks like a compliant spill. On the second one, what we're seeing there is what looks certainly on the surface to be a non-compliant spill. And you look at that, you say, oh yeah, it's plateaued out. It hasn't reached its flow to full treatment point, and yet it's spilling. So on the surface, that looks like it's non-compliant. But if you compare that plateauing, it's not just plateaued; it's pretty much flat-lined, and that's an example, potentially anyway, at least, of the analog output being maxed out at 20 milliamps, so it's reached its maximum point and just plateaued out there, not necessarily because it's reached the flow to full treatment point. So I'm not saying it's wrong, I'm just saying that there's a question mark over it, and it's something we could look at. So what bringing the digital values in, it gives us more than just that analog value, and we can start to look at some of the other reasons for potentially what looks initially like a failure. So we're starting to look at enabling the PFF permit requirements to be referenced against spills, plot those flow curves over all the overflow events, understand the magnitude of a fail. Is it just tiny margins that we're looking at? Is there small things that we can do within our process to improve it? Or and identify when the spill to storm tank took place. Again, might be small things we can do in our process to improve that. Ensure storm tanks do not fill and discharge prematurely, which I think most speakers have mentioned, and as I say, diagnosing those possible scaling issues. But also, as say, with a digital platform, you don't necessarily need to worry about the scaling issues so much. So that's kind of where we're coming from. What we're looking at is a SIVA cert solution. It's by no means complete. We are very much in the early days of development, and what we're looking is to simplify that dashboard with instantaneous visualization of compliance status. So overcoming some of those issues that we saw on the previous slide, instant notification of pollution incidents pending, advanced warning of network devices, and asset health status. So we've got now a chance to be able to put some measures in place to prevent a spill potentially, and then as I say, that effortlessly evaluate the asset status and resources required to provide to site visits. So you don't just go to site blind, not knowing if you need a spare transducer or transmitter or what it might be, that you have some understanding of the health of the instrument, some messaging potentially of what else might be the issue. And then, of course, in terms of security, all the data taken into MySphere, those 3 layers of security, so you're cyber secure, and then finally, save time and money with the event and commented history for the audited report. So again, you're not going back revisiting an event that happened 6 months ago, and trying to remember what happened. It happens. It's commented on at the time. You attach, some email or something you may have had from the Environment Agency to accept the reasons for the spill, and or the missing data or whatever it might be. So we've got evidence along with the report, and so that's the big idea. At the moment, it's a bit of it's very much, as I say, in the early development stage. And this is really a bit of a shout out to the industry to say, would you like to join with a tech company like Siemens? We need to collaborate. We need to work together to try and bring a solution to this issue, we think. And, certainly you guys are expert and proficient as end users in managing water. Siemens as a tech company, I think we're pretty good at automated processes or automating reporting, and certainly in terms of where we are now with data science and analysis, I think we're pretty much up there. So I think what we need to do is try to bring together joint areas of expertise to deliver a solution to the problem that Mark Swain, I think Kathy has already alluded to, is this is now become quite an onerous regulatory burden, and it needs looking at in a more holistic way. So that's a shout out, I suppose, to the industry. If you feel like you'd like to collaborate with Siemens, then please contact me, and we'll try to put together jointly a solution that fits, that's fit for purpose. So I'm going to move on now to just to give you an idea of some of the things that we have done already, to a demonstration from Stephen House. Stephen's going to demonstrate some of the things that you might be able to visualize more easily in a cloud-based platform.
Okay, can everybody hear me?
Yeah,
we're a bit quiet, but yeah.
Thank God for that. That's step one. You always feel like a radio DJ when you do these things because there's no feedback at all. So hopefully you can see my screen, which has got some different coloured squares on. What I just want to talk about very briefly before we look at the data is collecting digital data, and really there's no negatives. When you look at digital data, it's less susceptible to noise. That's why we've all got digital TVs now. You get much crisper signals, and we're not worried about a noisy two-stroke motorbike driving down the road and our TV signal going all over the place, because it doesn't get affected by that. Scaling is not an issue. So you looked at Darren's slide earlier on. That could be that the 20 milliamps is scaled incorrectly. Instruments will carry on reading regardless of the scaling. The milliamps is a form of output, and really as well as all of that, there's more information. So one of the things that we're looking at really, and what you can see on the screen, is splitting out the heart information from your existing instruments. And you may not be aware of this, but a vast amount of the instruments that you've probably already got installed have heart communication. You may have used it for configuration, and then it's not being used and you're just using your conventional 4 to 20. But here, this is a data collector that's connected to MindSphere. So this is the built-in web browser for the device, and it's bringing back. I have an open channel flow meter here, and then I have another device connected to it, which is a radar sensor reading level, and these are my process values. So if I was using my 4 to 20, this is what I would be scaling over my 4 to 20. But just to give you an idea of what other information is sat in the background, I can go into here, I can see my tags, my descriptions, and then when I go to my process values, all Heart instruments can give you 4 heart process values, and that's not specific to Siemens instruments. It's all instruments, but it's also bringing back my units as well. So there's no question marks on here. So this one here on the flow meter is my daily total. So at midnight every day, this will go to 0. I can then see here the status. So this NE 107 status, it might not be something you're familiar with in the water industry, but this is an asset monitoring standard that's been set out by NMOR. So it's used in the chemical, pharmaceutical, and oil and gas industry. So it's not a standard that Siemens have made up. And then down here, you'll see another interesting diagnostic parameter is configuration changed. So if anybody changes a parameter on this device, this configuration change flag gets reset, and you can't clear this without a software tool. So for these jobs that have MCERTS surrounding them, where you've got to prove that nothing's changed over the lifetime of the device, this is ideal. It's already built in to your heart instrument and you're not using it. So that's how we collect the data. This device, you can see it's updating here, and it's pushing the information to, in this example, to MindSphere. And what I have on MindSphere, I've got 2 apps running here on this screen. The first screen is what we call Fleet Manager. So I can have up to 8 devices connected to this one logger. And I can see here, this is just my open channel flow in simulation, so that it's going up and down continuously. But you can see here, the totalizer, the top green one, is counting up. And this is just a trend. And this is relatively easy to do with any logger to trend the data. But it's always useful to see, because it can give you indications of long-term issues. And then here we have the level sensor. Now, one of the nice values that you'll see on here in a minute is something called echo confidence. And that's how well your level sensor is performing. So if you think you're having an issue, you're actually looking at the value to tell you how well it's performing remotely before you even go to site. So what we've done with this data, rather than just trending it, we've surrounded it with what we call an app or an add-on. Yeah, and this is it here. We had to give it a name. It could have been called Steve Howe's, could have been called anything, but we've just called it EDM MCERTS for now. And I've got 2 devices, 1 level sensor and 1 flow meter. And under here, you'll see my configuration change counter. So if that counts up, I know that somebody's changed a parameter on that device. So there's two of those because there's 2 devices. I've got my flow, my distance, and my level for my open channel flow device. And then down here, I've got my EDM, echo confidence, and all of these are being logged. And it amazes me, still in this day and age, we're going to digitalize everything, but everybody still likes to see their old analog dials. I think they need to have something that they can tap, going back to the old days with the old pressure gauges. But we can see at a glance here, that my MCERTS, for some reason, level has gone too high. My echo confidence is fine. My daily total, and this is real-time data being updated every 2 minutes, is approaching my discharge limit, and everything is there at a glance. But if I go back to my grid view, I can start to have a look here, so that my MCERTS level, it's not happy. And what I have under here is, first of all, I can set it up, but I won't go into that. I'll show you the data. So we can see at a glance when we've had these critical alarms, and I can filter these. So you can see there one missing data. So I had missing data because I had it turned off. It's in my man cave at home. It's not actually on a site somewhere. It was turned off for 1 day, 23 minutes. You still get that alarm. You will get that alarm if I go back to my settings, there's an alarm here, update frequency. So I will get an alarm after 4 minutes to say that I'm missing data. So I'm not having to sit down and analyze all my data straight away. It tells me what's going on. And then these other critical ones are showing me the alarms. Now, when I click on any of these, I get a summary at the bottom of my min and max values during that period, the sum. So, and I think we've put standard deviation on there as well. And on my event graph, I can see my data and I can zoom into that and look at any of these data. So what I've tried to do is simulate a spill here, sorry. And so when it's gone to red, that's a spill, yeah? So I can see my level going up, and these grey bits here is when it's had data missing, and the yellow is obviously a warning, and green is healthy. And because this is simulating, I'm getting a lot of spills. Of course, hopefully you shouldn't see this in real life unless you had a profile like you saw before with the noise profile. So you get that, and then at the end, we're looking at putting that into some sort of report. So for this particular asset, so my MCERTS level, I can see here it's been online for 2 days, 23 minutes, and I can see, well, this particular critical alarm I've had 2 days, 23 minutes of alarms, and I get a summary of everything there. If I want to change my date range, then I can do that. Put my date range to today or whatever I want to do. I'm trying to remember when it was online, to be honest with you. I'm struggling. And it will update that information for me. Once I've got that, then I can export that information. So as we said, this is early days with this app. I've got one asset on here. As you start adding, you'll get more and more of these little symbols coming up, and these will change color with these alarms. And then we're looking at doing repeat offenders, so you can drag that and put in that into a repeat offender list. So if you're getting noise issues on site, you can send somebody out to investigate it and keep a closer watch on that one particular asset. So there you go. I won't say any more because I'm conscious of time. So I'm open to questions if there's anyone. So thank you very much for your time.
Well, thank you very much, Darren. Thank you very much, Stephen. Perfect timing. So we have got about 4 or 5 minutes for questions. Any questions? Any offers for collaboration from the water companies? I think it's interesting, and to be honest, I think this is a way of dealing with it. What sort of collaboration are you thinking of, Darren, Stephen?
Yeah, I mean, we're looking for trial sites certainly, and we've had an offer, so that's perfect. We've just had that in the last week, so that's perfect. It's a good start for us. And really it's about then what does the water company want to see, and how would they, in terms of their user experience, how would they like to visualize the alarms, the alerts, are they the messaging, so it's all about that user experience, and also, I guess, how deep do we need to go? So that's probably of most important to us. Is it a requirement that you'd want to see, just like as I showed there, the FFT alongside the EDM and some monitoring of the asset health, or would you like to see pumps? Is there a pump failure? Is there power outage? Is there so how deep do we have to go in terms of data monitoring and to satisfy regulatory compliance, I suppose. So it's that sort of dialogue that we'd like, and to be able to present a solution that fits with the industry's needs, and obviously the more wider that we can cast our net, if you like, to get everybody's input, then hopefully we'll cover all the bases that we need to.
Laurie, do you want to chip in with your very well made point.
Can you hear me? Just put your thumb up. Thank you. Yes, Laurie Reynolds from Acromatics. I'm keen, Darren, to try and develop a metadata standard for the EDM application and many others in the water and wastewater sector. I think it's really important. As I said in my statement, my question in the chat window there, Stephen demonstrated very powerfully how Echo Confidence could be displayed on his analog dashboard, and then also track an audit chain that might have been made by an authorized or not authorized operations person. I would like to see a similar metadata standard describing the installation, describing the manhole, describing the distances, as Dave illustrated, how important the distance from the invert and the level was within the chamber. All of the geometry of the way that the sensor is installed should be captured in a more standardized way than we are able to at the moment. Every one of the vendors has their own particular metadata standard relating to their devices. Those type of measurements and data needs to be more standardized. Battery health, for example, critical that you know that your battery is going to potentially fail within 2 months' time, so you can schedule a replacement when your crews are next in the area. All this kind of data relating to the asset management of the data as an asset needs to be more, in my opinion, standardized. And there are various standards that I'm working on at the moment. There is something called MQTT, which is a communications data protocol standard, but you can name the topic and the namespace, anything you choose within that. So there's an initiative called Sparkplug, which is running in the manufacturing sector to try and standardize those namespace definitions more effectively. Now, when you're at the beginning of a new piece of regulatory legislation, such as the EDM regulations that are coming forward, this is a great opportunity to for the industry to come together and to develop these standards. They need to be informed by the operational requirement, the asset management requirement, and also, of course, the supply chain and the integration of all that data into the kind of intelligent systems which we're capable of being able to develop these days. So that's where I would like to see the collaboration being taken forward. We have WITS. People may be aware of WITS, but WITS is a protocol defining how you transfer the data. It doesn't actually standardize the data messages in the messages themselves. And that's where I think there's much more effort required.
Also, Laurie, in principle, it's coming in the wastewater BSN standard because you can guess who's written into it. And there's a IWA. I've got an action at the minute to organise an IWA interoperability workshop, which is somewhere we probably discuss it.
Our next speaker is Brian Moloney, who is the co-founder and managing director of StormHarvester, a company that is dedicated to playing a major role in using machine learning to develop tomorrow's intelligent sewers and the smart recycling of rainwater in building construction. Brian is a civil engineer by background and is passionate about using smart technology to improve the effectiveness and efficiency of the world's aging sewer networks and wastewater treatment plants. He's going to talk about a case study of using intelligent sewers and how we can make alarms smarter.
Well, thanks very much, Oliver, for inviting us to come in and present today. I'm really excited actually about this presentation because I think a lot of the challenges that have been discussed through the different speakers and particularly what Mark Swain and Catherine mentioned in the chat as well about not having all the alarms, but it now being very difficult to manage the amount of data and the amount of information that you're getting. And that's exactly what I want to present here and demonstrate. Last year, Wessex Water, through their marketplace, put out a call through the marketplace, and it was intelligent sewers, can we make alarms smarter? And it was really to address this exact problem that their control rooms were being overwhelmed with the number of alarms that they were getting during particularly periods of high rainfall. So all the EDMs and all the level sensors, pumping stations, across the network, a large percentage of them would hit 70, 80, 90%. The alarms would go off, and what ended up happening was the big red button was hit and basically silenced all alarms for a period of time until it came back to a manageable level. So they ran a trial through the marketplace where they wanted to identify a technology that could assist in identifying the correct alarms and point their ops crews to the actual, the real areas where they could cause and have a benefit. I'll get in and we'll do. I'll go through the trial itself. There we go. Now, first of all, let me give you a little bit of background on where we've come from, where StormHarvester has come from, and what we do. Essentially, we started looking at this problem before the last AMP. We could see that all these level sensors were coming in across stormwater and wastewater networks. And we could see that the weather forecast prediction services were increasing, getting more and more local. And when we put these two things together, we could see that there was some significant benefits that we could have here using the hyperlocal rainfall forecasting and using the data from the sensors to start optimizing the information that's coming back from the sensors and use the sensors more helpfully. So after 4 years of research and development in partnership with Queen's University in Belfast, we've put a total of nearly £2.5 million of investment into developing the system. And we're now happy to say that it is out and it is commercial. And we're going to go through the trial that we did through the summer with Wessex Water here. We also won, my background is a civil engineer, so it was a great privilege to win the best new technology at TechFest, which is the Institute of Civil Engineering Awards last year. And we also won the one at Future of Water. Okay, so what we're doing here and what we're going to show is specifically we're going to demo the Wessex Water trial and the system that we ran with Wessex Water. And Jody Knight, who's the asset technology manager at Wessex Water, is available for any follow-up questions. And he was hoping to get on, but he had a conflict in his diary to be on the line for this system. But he is. I was speaking to him this morning, and he said if there's any questions or anybody wants anything specifically from Wessex on the trial, he's happy to interact with them, and I can put anybody in contact with Jody. So essentially what we're doing here is taking hyperlocal rainfall and taking the asset data, and I'll speak a little bit about what we're taking from the asset. Essentially, it's the level data from the pumping stations and the CSOs. We're running it through our machine learning system, and it's allowing us to give more intelligent sewer warnings. So to use the data that's coming from all the sensors that have been across the network, but to use it in a smarter way now, where we're actually pointing to the problems as opposed to just getting alarms and false alarms and high level alarms that really are not indicating breaches of permits. The machine learning system, the machine learning alarms system that we've built is customized to the stormwater and wastewater networks, the stormwater and wastewater industry. We haven't necessarily just taken some machine learning techniques from other industries or some standard out of the box machine learning. We've built an approach that's customized to working in this domain. And that's why it's taken several years. Okay. So Wessex Water, as I said, in October last year, so over a year ago now, went to the market through their marketplace. The Wessex Water marketplace is what they use to identify technologies that address a problem that they have within their organization. It's a really, really, really good platform for early stage technologies like us to actually get in and get working and get trialing on a live environment. And the trial, as I said, was intelligent sewers. Can we make alarms smarter? I think they had about 60 different companies they spoke to. They narrowed it down to 16, and we went forward for a 3-month proof of concept on the Bath catchment, which was the catchment which had approximately 100 sewer level sensors and 9 pumping station sensors as well in that. So what they were requiring was real-time alerts. Basically to identify which of the alarms and the alerts in their network or which of the sensors were identifying a problem at a moment in time and which were just regular alerts or regular overflows. And what they want to do by doing this is they want to be able to proactively direct their maintenance crews. Instead of the maintenance crews going around on a cycle and going from site to site, on a schedule every 6 months to visit a site, they wanted to actually be able to proactively manage the crews. And as well, in periods of wet rain, they want to get the crews to the right places where they can actually have a benefit as opposed to being overwhelmed as they were at the moment. And it's a significant problem because they're spending approximately 5 million every year in going out on their maintenance. And one of their major frustrations is they're going out and the maintenance crews are very regularly arriving to a site, and there is no there's no problem. It's just scheduled for maintenance. They go out, there's no issue. They still jet it because they get paid when they're on site to jet it. But it's not necessarily something that's giving any benefit back to the organization. So they're trying to eliminate this. So in terms of, I'll explain how the system works and how we got here, and I'll go through all that in detail. But what we're doing are the results of what we did with Wessex. So we ran the system live on the BAT catchment for 3 months, so on a live site. We estimate that over that time, they would have had 3,500 control room alerts. That was an estimation that we've sort of come up with Wessex. We gave them over that period of time 136 alerts from our system. They audited each alert and they went to site when required for each alert. And they kept a register of what they found and if the alert was relevant or not relevant to them. And 90%, 124 of the 136 alerts were determined to be relevant to them. 60 of those alerts 60 of the 124 resulted in blockages being identified and blockages being removed or restrictions being removed from the network. So when we started off with 3,500 alerts, we brought it down to a manageable number, which the ops crew could manage, and 90% of what we were doing gave them identified issues on site. And as far as we know, and Wessex have identified, we didn't miss anything that they would want to have seen or they would want to have got somebody out to the site to address. Okay, so how did we do this? How does this work? So we have a 3-stage process that we operate. And I'm going to go through each stage in a little bit of detail. The first one is the hyperlocal rainfall and the sewer telemetry data. So we're taking various different weather forecasts, including the Nowcast. We've built a radar system where we can visualize how the Nowcast system is working. And we're inputting all that information into our system. We're also inputting the information from all their sensors across their network. So any of the sensors they had in the wastewater network. So in this instance, they had 89 CSO level sensors and they had 9 pumping station level sensors. So all of this information gets pulled into our platform automatically. And then the process is to match and clean the data. And this is a really, really important aspect. Any machine learning system is only good as the data you send into it. And within the industry at the moment, there is a lot of QA/QC going on with standard techniques that have been developed from other industries that have been imported into our industry. And we believe this is not the way to do it. We have developed a customized QA/QC system that is specifically designed to clean data from sensors in the wastewater network. Because we see different phenomena across the wastewater network, we're touching and we're identifying exactly what those phenomena are, because we've dealt with hundreds of systems here across different utility partners. And we're seeing repeat phenomenon consistently, which can be identified and can be eliminated from the data. So what you see on this system that we've shown here, this would be somewhat typical of the data we would have got from one of the sensors at Northumbrian. So you see the sewer level is in brown, and the corresponding rainfall from our system at the hyperlocal resolution is showing on the bottom. So what our system does, we pass it through the cleansing system. First of all, it identifies the false data. So in this instance, we had what we thought looked like step irons. We had false level from the benching. And typically you'll always get across all sensors, I think about 90 to 95% of the sensors we're looking at have erroneous null data randomly placed across the sensor. So what we do is we pass that through the cleansing system. But that cleansing system is based on our machine learning. So we learn the signature, we learn what the level is, we would expect the level to be in dry weather and wet weather, what we call the signature of the CSO. And we use that to replace the erroneous data. And that gives us, when we clean that data set, it gives us something that looks like this, which is something we would expect to see. And the key behind that is knowing what you're expecting in that area and then identifying where we have trends like erroneous high level, erroneous low level, null values, So it's a detailed inspection and cleansing process to cleanse the data, because, like I said, the data is only as good as the machine learning is only as good as the data that you have to input that. The next thing we do then is we develop a threshold prediction for each asset. So it's an operating window, which we determine to be a safe operating window for each system. So what our system will do, the machine learning system learns the behavior of the asset relative to the hyperlocal rainfall. And then from that, it can predict what the operating window should be going forward. So here you see on this sewer, I've just turned on the operating window, which would have been the safe operating window for this particular sewer. If the level breaches the operating window, then there is an issue on site, and we potentially have a problem developing on that site. And the operating window is inputted as a prediction. So we'll look at that 6 hours in advance. We'll give you an operating window for that sewer for the next 6 hours. And then we will wait until we get the data from that sewer. And once we get the data, we will identify, has it breached or not breached the threshold level. And if it has breached it, then you're following on with an alert or an alarm. The second one is our gradient mean trend analysis. So what we're doing in this one is we're monitoring the trends across the sewer. The difficulty with monitoring trends is that you've got your rainfall, which is throwing your trend out, which is throwing your daily pattern out. So the first thing that happens here is that we basically reverse engineer the rainfall. We take our rainfall predictions and we take them away from the sewer level that we see. So we try and rebase everything down to what it would be if we didn't have the rainfall, if it was dry weather. So what you see there is the ML system has adjusted the level down. And then we look at different trends. So we look at things like what are the bottom 10%, the mean of the bottom 10%, and we'll look for a trend in that. We look for a trend in the top 10%. We break the data down into periods, down to 3-hour periods, and we look at the mean of that 3 hours right across the day. So there's 9 different methods that we're using across a trend analysis to identify trends in the data and identify when we go off trend in the data. And you can see on the screen there that we're starting to increase the level, and you can almost see like the train tracks have gone off to the left, or they're increasing. So that's identifying to us in that instance that there is a blockage or a restriction or something forming in that sewer that they need to be identified on. And the last one is a really interesting one. It's a cluster analysis. So what we do is we group between 2 and 5 sensors together, and we monitor their behavior relative to each other over time. And then we continue then to see does that behavior at each different time period, is that relative behavior the same? So it's a process that we do where we monitor, where we put assets into a group, and then we monitor the relative performance of that group to each other. And then that identifies if one asset goes off trend, or if one sensor starts to perform very differently, then we know, okay, we've got a problem, or we've potentially got something we need to identify here. So the outcome of this proof of concept that we ran with Wessex Water is that Wessex are moving in the new year to a condition-based sewer maintenance system. So they're moving away from the model of, just having somebody visit the site once every 6 months, irrespective of what the sensor or the data is saying. And we're moving into using these sensors to inform the maintenance crews as to where they should be at any day or at any time, and schedule the maintenance based on the asset condition, not based on just a timetable that they have to go out on a site. So this is ensuring improved compliance, because we're picking up sewer events and sewer blockages, sewer restrictions a lot earlier, so they can be cleared a lot earlier, so they're not resulting in non-compliant events. We're managing the volume of the alerts, so the control room aren't getting overwhelmed. And it was interesting to see the confidence from the ops crews growing over the months of the proof of concept, because they were being tasked with keeping daily records of exactly what our alerts were saying against what actually happened when they went out on site, taking pictures of what they recorded from site. And then as the data grew up, they could see that 9 out of 10 times when they visited the site, based on one of our alerts or one of our alarms, that there was in fact something on the site that they wanted to see, or they needed to be there, or they were able to identify and remedy. We've talked a little bit about the maintenance crews. There's a carbon reduction because we don't have as many trucks on the road. We're only putting people on the road when we need to actually get out and improve the site. And the assets are being used, so we're able to run the sewers at full capacity more often because we're identifying slow blockage build up or early blockage formations, and we can get out and we can get that. Another interesting one that's not on the presentation screen there was one of the things that we're interested in doing and interested in looking at, and we've started looking a little bit at this, is if you do have a pollution incident in an area or you do have a curtilage flooding incident that you have to report, if you can go back to your sewer system and you can look at all the sensors you have in that area and they're all performing within the threshold that you would have expected them to perform, then that evidence can be used to put forward to demonstrate that the curtilage flooding event may not have been as a result of out of sewer flooding or a result of one of the utilities sewers. So if we have what the operating window of the sewer should be, then we can demonstrate that, okay, we were within the correct operating window of that particular sewer. So that was quite an interesting additional benefit that we hadn't foreseen at the start, but it's something that we're looking to investigate more. So I will now just jump out of the presentation and I'll just do a quick demonstration of our portal. So what you see here, hopefully, is the portal that we were running for the trial for Wessex Water. And we don't necessarily have to provide the portal to the utility. We can integrate with some of your existing services if that's easier, or some of the existing visualization tools. But as a standalone, when we ran this as a proof of concept, this was the portal we provided to Wessex. So we can go into the back catchment. We can start to see all the different sensors that they have in the area. So I can turn off that's the wastewater treatment works, which was outside the town. I'll just turn off the radar for a second so we can see what we're dealing with. I'll turn on the pumping stations. This is the main pumping station in the center that was pumping up. It was an ex-wastewater treatment site that's been decommissioned and a pumping station put in. And this is the remainder of all the CSOs and the sensors. And we can click into any individual one of them, and it will give us the levels at that location over the last week, and we can go back several months to look at the data. It'll give us the prediction of what we're expecting going forward. So we've taken the portal as you see it here is a snapshot in time. So this was taken towards the end of July during a big rainfall event. As you can see, the rainfall coming up in the future, and you can see our prediction window, and you can see how the prediction window changes during periods of rainfall so that it accommodates the rainfall that's coming. And you can see our prediction window into the future is shown based on the rainfall. So the prediction window increases when you've got a major rainfall event, because this was on the portal. I can show you the radar. This was the biggest rainfall event I think we had over the period of time. So I'll push the radar on forward and we can see it was quite a significant event out here with two separate rainfalls coming. And on the portal then it's going to identify any sewers with issues. So these two are being shown with issues at the moment, and I can view them at the bottom down here. And this will show the window that we should be within, and then we can see how this sewer has pushed up, and at different rainfall events it's not coming back down. So it's increasing, but it's not coming back down, staying at a high level. And this was one when they went out, they identified that there was a blockage restricting the flow here, and that was subsequently cleaned. You can see probably something similar below for another operating asset, which I think had something similar. Yeah, the flow pattern had started to increase over the course of a couple of days, and then the threshold is breached, and there's an alert issued on the basis of that. So we're picking up blockages, alerts. We're also picking up telemetry issues. So if one of the sensors has an issue, then the system will pick it up and it will identify it, and it will be given us. If it doesn't look like a blockage from the machine learning system, it will identify it as a telemetry issue or as a data fault or data failure. So hopefully that gives a little bit of an overview on the system and the portal and all the different assets there that are being monitored in real time. The system took about a week to set up and get operational, so it's pretty quickly. It works pretty quickly. We API'd the data out of Wesgate's system, and we were integrating with one of their existing technologies that they had for managing the data internally. So it was one of their data management / telemetry providers that we integrated. We were potentially to integrate with and take the data straight out. And it was a pretty quick, pretty seamless process from the Wessex point of view. And going forward, we're looking to integrate back into that telemetry data provider to give our alerts and our threshold predictions inside their visualization platform, because that's the one that the utility company is using at the moment. So I think that's mostly what I wanted to touch on. Is there any questions that we can ask? Like I said, we can anybody that's interested, we can put them on to Wessex if they want more information directly from the utility about it. But we are interested in running other POCs or trials with other water utilities for this system. And we're also interested in any of the sensor providers or any of the telemetry or data providers who might be potential partners for us as well. We're very interested in collaboration. We're very aware that we don't do everything. We do a small piece of the big pie, but we think we do it very well now, and we've got good testimony from a water utility telling us that it's worked really well. So we're really interested in collaboration. So if any of the other companies, technology providers or telemetry providers, sensor providers are interested, we're certainly interested in speaking and talking to them. And of course, if any utilities are interested, we're definitely interested in that approach as well. So is any other questions, or Oliver, I'll hand back.
Questions anyone? Bit of an echo on myself there. I think we've seen this morning three fascinating ways of going, and I hope the water companies have picked up that there are technologies out there. We're worried about FFT flow in particular at the minute, and where I see, and I discussed the last week, Brian, where I saw you had the spill there, and in some ways, okay, it would take a little bit of adaptation, a little bit of working in collaboration with the water companies. And I'd say the same with Siemens technology that we saw before yourself, where you had that spill event, replace that with an FFT, and you're manipulating the data and the visualization. And I see it as a very powerful tool. And yes, I see that as a collaboration with the water companies. And if the water company is looking for funding, I see the innovation fund being the Ofwat Innovation Fund, which is, I think the details are going to get announced later this month, being a perfect project for that. Because of course you're protecting the customers, you're protecting the environment. So those are two, and it's an active problem at the minute. You're ticking a lot of that. To me, sounds like an innovation which has a massive real application in the industry right now. What, from the water company people we've got on the call, am I wrong? Is there that potential? Is this the sort of way of handling the data that the companies are looking for?
It has got potential, Oliver. Yeah, it's one of my concerns would be that it needs to be accepted by the regulator at the end of the day. So what we're actually trying to prove as a result of looking at the data and maybe reducing some of the noise that's in there is whether we're doing that, whether we should be doing that, and whether that's going to be acceptable from the regulator. So yeah, it's an interesting concept. I do wonder whether that's we need to do, if we're doing a lot of work on it, whether that's going to be fruitful at the end of the day or not, depending on how it's viewed by the regulators.
Yeah, I mean, from the regulator point of view, and we have a few of the regulators that do want to chip in, I could see in terms of serious and pollution events that being incredibly relevant. That's, as I was saying in my presentation earlier, that's the collection network. A bit of adaptation, admittedly. There's no reason why that couldn't be applied to the treatment works. And then we suddenly have, and to be honest, it's more like and I remember, I'm old enough to remember opera PBC. It's touching on opera PBC, process-based control, or I don't know, database visualization maybe, and it's certainly touching on that sort of concept that was probably way before its time in reality. I think somebody correct me if I'm wrong, but process-based control was about 2010 as an upgrade project, and I think it was like most of these technologies, it's probably a good 10 years ahead of its time. And I think we're more and more we're moving towards that approach. More and more as we're getting into that holistic system, we're gathering the data, but it's helping everybody to manage it. And I definitely see that as a concern within the water companies. Is that how do we manage these literally hundreds of thousands of bits of data? And the only realistic way we're going to do that is via either of the systems we've seen today, or something that's been worked with the water companies in a collaborative way.
Can I just jump onto something, Oliver?
Yeah, Michael.
Just coming back to Mark's comment about the regulator, and I sit in a smart water world as part of the Swan Forum, and that includes dirty and clean water. And this involving the regulator in discussions is not a problem. Not a problem. It's something we have to do because we are moving to a world. Once upon a time, everything was done manually, so there was control there, and regulatory samples were taken, and people did it. And we're getting to a situation now where sensors can do a lot of the jobs. Artificial intelligence is predicting things. So the regulator very much has to be involved in these discussions about the way forward. And I was having a discussion with the water company yesterday about the difference maybe between information that's used for operating your system more effectively, and that's really up to the water company to decide what they want to do and how they want to use it. If that improves their regulatory compliance as a side effect, that's a bonus. So you don't necessarily always have to have every single thing you use, being used for regulatory compliance. Just operate your system better, and you'll comply anyway. So there's something in there as well. So I do take the point the regulator's got to come along, but sometimes just use these things that Brian's been talking about as an operational tool in-house. It's yours. You use it to operate your system better. And in the same way you might use pressure switches or level switches or something like that. So see it as a tool towards a goal rather than a thing you've got to keep reporting back on, maybe.
Jonathan, you've made a very good point in the chat.
Sorry, Oliver, I would agree with Mike there. I think that's the way, exactly as Mike has described there, that's how Wessex are seeing it as an operational tool for themselves internally to improve their own processes. And by doing that, then they will improve their overall compliance ultimately. But it's really the in-house tool to allow them to get their ops crews to the right place at the right time, so they have less, at the end of the day, they have less non-compliant events.
And Jonathan in the chat made a very good point, is using existing assets is key for network and treatment works management, using such intelligent software as a CapEx benefit reduction in overall expenditure. Absolutely. But to maintain the input data, strategic maintenance plans need to be put in place to ensure asset availability of these instruments. Yeah, and I 100% agree. I think we've seen from what we saw presented by Darren and co, we've got that potential as well. So the assets, for the instrumentation assets, we've got that potential. I mean, HART is this relatively modern protocol that's only been around for 30 years or more. Yet the water industry hasn't really particularly used it. NEMUR guidelines are there. There is that potential. Is it, Mike? You probably got something on this. Why don't we use this sort of potential that's there, or Darren, if you want to, or Stephen, if you want to chip in?
It's a good question. I really don't know the answer, as Darren alluded to in his presentation. Good morning, Darren, by the way. The HART protocol is extensively used in gas detection for whatever reason. It's all, it's just a part of any gas detector's standard offering will be the HART protocol. We had it available as an option for, you're quite right, 30 years in my executive life in the instrument world, maybe more, the HART protocol. I can't remember when it came around, but nobody uses it. It baffled me. Never understood why people didn't use it, but they don't. I think the water industry was just tied to its 4 to 20s and 0 to 5 volts. And conservatism and inertia just couldn't get around it.
Are we starting to use it now? Because I've certainly seen, and we've seen ABB with ABB Ability. Endress and Howes have had the heartbeat technology for a number of years.
Yeah.
And others obviously use it. So are we waking up to it?
Yeah. Sorry, it's Darren. Yeah. I mean, I think there's a number of things here. HART protocol has been around since I think it's 1979, I think it first got released, so certainly in the early 80s. But it's very much been considered a commissioning and diagnostic tool in certainly in the last 20, 30 years. It's only been in the last 5 or so years we've started to wake up to the idea that we can get far more from that digital signal than just using it as that diagnostic tool, as I say. And particularly with the advent then of cloud-based data systems, then it's made far more sense to use that. So it's never been considered in control because it's quite a slow protocol, to be honest with you. Unlike sort of Profibus or some of the other communications protocols, it's never been used or considered in a controlled environment. But for monitoring purposes, actually, it's really beneficial. And as we've said, as you say, it's comes as standard on a huge amount of instrumentation. It's just never used. So the key for us is to unlock that trapped information, that trapped data that's in standard instrumentation, and do something more clever with it.
I'm certainly potentially. I don't think there's been the telemetry capacity, and as we move to a cloud-based environment, that does allow it. Maybe allows more, but yeah, I must admit I was sat at an Institute Measurement Control meeting and on digital transformation, going, well, there is no standard protocol for the water industry, and the people there who are mostly from nuclear, oil and gas were, I think, a bit aghast, really. We tend to. It's something that's been at the back of my mind for years is well, why don't we have a standard? Why don't we standardize on whatever we do? Laurie, you're putting your hand up.
Yes, Oliver. I mean, there are so many standards out there to choose from. Every one of them has a different business and technical argument in their favor and against them. I believe that what's lacking is an understanding of the complexity of the technology options we have here,
And when we talk about protocols, you have to qualify what type of protocol you mean. Are you talking about a communications protocol, where you organize the bits and bytes on the line? Or are you talking about a data protocol, which is the way you organize the content of the message? And the two are very, very different. We haven't really focused at all on message protocols at all in the water sector. Indeed, many industries haven't. But this is why I come back to this, the importance of these message protocols. We need, as an industry, to be working together to develop these, this better understanding, and then spread that understanding to the people who need to know, which isn't everybody. I mean, so much that the utility has got to take on board these days that you wouldn't expect them to necessarily be an expert on whether or not they should be using HART or not. It's really a function, I think, of the supply chain and the integration, particularly of new and legacy technologies, which is where that expertise needs to lie.
So we've got a point from Jonathan Higgins. We need to establish a solid relationship with cloud-based technologies / communications in the water industry for process control monitoring, particularly around security. Yeah.
Well, yes. I mean, who wouldn't disagree with that statement? The problem is you have to unravel that statement, because there's a whole series of different technology and architectural questions which that question begs. And I think this is a classic example of how we need to understand the overall architectural choices which need to be made to develop a roadmap or a strategy of how we move forward as an industry, as a global industry, and as an export opportunity.
Right, what I'm going to say is we're now 1:10. If everyone comes back for 22, then fantastic. If you want to stay a bit more of a chat, then equally fantastic. As most people who know me will know, I'm always up for a chat. But if you do want to leave to get some lunch, to have a comfort break, etc., then do. If not, then stick around for a bit of a chat. But see everyone back here at 22. So I'm an instrumentation person, so I'm not a protocol person. I'm not a comms person. I can see the benefits of it, but I don't know why we haven't moved forward. I can see from my point of view, data being absolutely vitally important. And to get that right, the sensors have got to be right. We've got to have things installed in the right way, in the right place, blah, blah, blah. Anyone who's read anything I've ever written will basically know what I'm about to say. Why don't we get it right?
Well, I'll just jump on that a little bit. The thing with the you said there we need data. Yes, we do. But the one piece that's often missing, and I'm completely biased being a water quality instrument person, is the collaboration between the movers and analyzers of data and scientists and water people who actually know what the wiggles mean. Because you can see an absolutely awful piece of data from a data scientist point of view, full of holes, gaps, noisy as anything. But if I look at that, and that's in my domain about water quality, I'll look at that piece of absolute garbage and say, well, you know what, the plant's under control. Don't worry, panic's over. Because I've got domain expertise and some metadata. And I sometimes, it's a drum I do beat, and I know Darren, from the Siemens point of view, particularly working with John Gaffney, people might have a different view. Sometimes I think we focus far too much on how many data points we've got and not enough on what it's actually telling us. And that's a misgap. I'm seeing lots and lots of presentations, in various forums with fantastic data analytics, but nobody's sort of winding it back to the physical parameter that they're actually measuring and whether it actually makes process sense sometimes. So we don't. I'm not sure we do need tons and tons and tons and tons and tons of data.
We need the appropriate data. Mark, you're making a point.
Yeah, I think the device has to. I mean, there's a world. I'm rapidly coming to a conclusion that we need a little bit more intelligence at the edge, and that the sensor's doing stuff in its own little world, and only really banging data out when it's needed or when there's something changed. Because otherwise, we are very, very quickly going to fill up, supermarket-sized servers with data which is 99.9999999% irrelevant.
Yeah. So
Anyway,
I've got hands up from Mr. Swain, Mr. Birtwistle, and Mr. Meaning. So
shall I go first?
Yeah.
Since you mentioned me first. All I was going to say, just listening to Mike there. Interpretation of that data is critical because one thing we found out by doing some on-site analysis of the infrastructure we've already got in place is that every site's different. No two sites are the same, and they've got their own individual problems, and they've got their own individual systems, their own different way of sending spills to storm. Everything's different. So unless you can interpret it and relate it to that specific structure even, then it's going to be a little bit of a struggle to find like some commonality across the whole range of the data set. That's the only point I'd like to make on that.
Can we just comment on Mark's point, Oliver?
Yeah.
Yes, you're absolutely right, but they're not. We need to classify the types of problems that we've got and then begin to prioritize those problems and then tackle them one by one in terms of understanding what the variability and uncertainty that's created by that difference. I don't agree that every site is absolutely different. Yes, of course, they're all different at the micro level because they've all got a different postcode, for example. They've all got different trees growing by the manhole. Yes, of course, they're all different in the local circumstances and context. But I think if we understand and classify the differences sufficiently well, then we can identify those that are important and have a big contribution and impact on uncertainty and variability, and those that actually are less relevant and can be ignored comparatively. So I think we tend to get bogged down in this view that every site is different, when actually there's an awful lot of commonality between the problems that we're working with.
What you find ultimately is, I think I probably talked about this a couple of years ago at the last WWEM, is that you end up in a situation where you've got three boxes in effect. You've got it's easy to do, this site's compliance, this site needs a bit of work, and then you've got the difficult to resolve box, which kind of sits there, and that's where you find a lot of your problems, which they're more difficult to understand what's going on, and B, are probably going to cost a load of money to resolve.
Duncan, did you want to chip in with your point as you were next?
Yeah, can you hear me okay?
Yeah, can.
Cool. Duncan works for Severn Trent. I think I really like Mike's point about people using the data sort of can see through the noise. But I guess my point generally is that putting sensors in civils assets, which just have been piped and concrete for a long time, and we're bringing technology to new places, and therefore the people operating the assets, the teams crunching the data, are sort of trying to step into a new world here with all these new sensors coming in. And I think education is super important to everyone within the organisation. So what I would really like is, where can I go to find somewhere that's going to explain all the different meaning, pulses, analog, heart, so that decision makers in organisations can appreciate these sort of technical issues. So people they know how to operate a plant, they know how an ASP works, etc., etc. But in terms of the technical detail of telemetry systems, there's not a lot of knowledge at decision maker level within companies. So that's what I'd like for the industry is, simple explanations of things, clear steer basically on what a company needs to get right to have a successful system.
I've said something very similar to the digital transformation group at Incident Management Control and said, can somebody give me a what would the Americans call it, a primer on this sort of thing? Because yes, I understand instruments, but I don't think a lot of people understand that higher that level of comms, and I think actually it's a very narrow group of people who do understand it, like yourself, Laurie, who've been involved in it for.
So how much do you think you'd pay for a primer course on this subject then, Oliver? Give me. Well, let me ask, who was it? Duncan, who just asked the question. If there was somewhere you could go to access that information, and Mike and I are working on something that could potentially offer that exact result, how much would you be prepared to pay for that? And should you expect to pay for that, or is that not something that I would expect there to be somebody in the Severn Trent organisation who has that background and experience? I mean, I've got 45 years experience in process automation in the water industry. I track all these protocols very, very carefully, and I understand most of them and can prioritize them and rank them depending upon different contexts and situations. Happy to share all that, but at the moment, I've got to try and build a business of some kind in this knowledge, and I think it should be shared more widely than just the group who are on this WIPAC forum. So it's a really important question to me at the moment, and I suspect to Mike, in terms of how we can monetize something from this kind of problem. Is this something?
I think I need to
go on. Sorry, Duncan, I was talking across you. You go ahead.
I think I need a 3 or 5 day training course and comms going from the sensor level to the right through to the protocol level. So sort of the end to end, basically, from a sensor to a system. I need to pay high hundreds, low thousands.
Excellent, good. So £1,500 for a 5-day course. I mean, I actually don't think you'd need a 5-day course. I think 1 day would give you as much as you probably need, and then you'd come back a year later and do the second module, the primer 2. Because you then have more experience of the kind of problems you are dealing with. And you'd also, importantly, be able to bring that experience back into the training course. And so I see this as being a network of sharing this kind of good practice. Now, we have probably too many networks at the moment. I think one of the problems with the water sector is that we've got so many of these knowledge sharing networks, but very few of them are commercially viable. And therefore, they fizzle out once somebody who's an enthusiast. Oliver has done a fantastic job at pulling the Flow Forum together for many years, probably longer than he cares to remember. But we need enthusiasts like Oliver to be able to coordinate this kind of knowledge base and keep it fresh and up to date. But no, that's been very helpful, Duncan. We'll get back to you on that.
Brian, you had a point.
I was just picking up on Mark's point as well. I think there's 2 things. It's very much that there can be too much data. So, for example, we started working in some of the sensors. Some of the sensors were feeding back seconds through the telemetry system, and it was overwhelming. And when we gave it to our data guys, and they thought, "Oh, this is brilliant. We've got so much data," but you needed to know the industry. A lot of that data wasn't relevant. Yes, there was more data, but there was much more irrelevant data in there. And as well as that, then when we actually looked across, 2 years of data, we thought, okay, there's so much data here. It would be easy to build the machine learning systems. However, there was 42 raid events each year that were in the category to which you could train the machine learning system. So when you actually looked at the data, you really need to know and understand the domain to actually know what you're looking at with the data. And we plucked a couple of data engineers, data analysts, machine learning people from different industries. It took them quite a long time to get up to speed with what this actual industry data was, because a lot of them, when they're looking at it, they're just seeing a big bunch of data. Great. And then, okay, this one looks rubbish. We can't do anything with this one. So yes, we can, because we know what that one is. Look, this is false data. This is false data. We peel it all back, and then we have a reasonably good data set with this sensor to work with. And the other point very quickly was in terms of each asset is different. Each asset is different and very quickly builds its own profile within a machine learning system. And then you understand the behavior of that asset. So the standard deviation or variance or how that asset performs, the system will learn that over time, and then it will understand what that sensor tends to do over time, and it can compensate or not compensate on that depending on what's right. So what we were seeing with Wessex was some of the sensors we were much more regularly having problems because of what they were in the environment. Some of them, had grills that were more likely to block. And once you start to see the trends and once the machine learning starts to pick up on that, then you can identify it to Wessex. And the ops guys sort of inherently knew that, but nobody had ever done anything because they'd never put the figures together to understand that asset is causing us much more problems. We should look at doing something there until we actually went in and did that research.
I think that point is a really valid one there by Brian. As we said earlier, as a tech company, we've got lots of interesting ideas that we can throw at the industry on how we can improve things. But ultimately, as the end user that has that domain expertise, yes, over the 20 odd years in this industry, I've got a certain amount of expertise. As Mike was saying, we've got Dr. John Gaffney, who's an expert in water quality, working for us, and yes, he's ultimately got a lot of expertise, but sometimes it is that real local knowledge that someone's got who's right by the site. It just says, it always does that this time of week or year or day or whatever it is, and that is really valuable, because what we're looking for is not when it's running smoothly. We're looking for those anomalies when it's not running smoothly, when there's a problem, and trying to pick those issues out. You can take weeks or months even to in water quality to find a failure.
But on that, Darren, there's also the case of, yes, it's always run this way, but also it's never run correctly either.
Yeah, that's what I mean. There's always this problem at this time of the week or day or whatever it is. Yes, we always put the push the reset button at that.
Exactly.
Yeah, it's interesting that, because you can look at something that might look bad on a trend back in the office, and you go to site, and it's actually an indicator of good practice, such as being frequently maintained, for example. So, unless you kind of get out there, sometimes you don't really know the background behind it.
Flow is not something I've ever thought could be from the office. You do have to down, to be honest.
Just one comment, if you can, just coming back into something which is also a big theme. We might also be guilty of trying to do too much too soon. And another theme that came up yesterday in the Swan Forum was think big, great, but start small. And that's what Brian's done there. Start with Bath, then do whatever's next, and just get the learning and get the base and the foundation and the confidence and that culture change locally within Bath. So if they do it in Bath, they might do it in Bristol, and then don't scare the end users to death with this digital panic and, oh my goodness, isn't it? So think big, start small, and then you get the user case right. You get the local information, you get the feedback, and you can start to build these little models, which I believe ultimately will be transportable. There will be things like Laurie said, commonalities. We can recognise the differences, but if we try to do it all at once, we're going to fail. So let's do that. Start small.
So, for our final session of this year's forum, we have a session all about the application of flow measurement technologies with three great speakers. First up, we have Pete Devine and Matt Wesgate from Vega Control Systems, talking about MCERTS Compact level sensors, so where you don't need the screen. We then have Rob Stevens giving us a case study of using technologies for very large flow measurement applications, in this particular case the Lee Tunnel, part of the Thames Tideway. And then lastly we have Martin Hardwidge of Katronic talking about something different, RAS and SAS Flow monitoring, i.e. process monitoring using time of flight technology. So in our first session of the afternoon we have Pete Devine and Matt Wesgate from Vega Control Systems talking about MCERTS Compact level sensors for flow monitoring and event duration monitoring. It's an interesting and important application coming forward in the industry, and the use of radar, which Pete and Matt are going to present, is a technology that's come on quite a long way, so it's going to be very interesting to see what's coming up. Pete, Matt, I'll let you take the floor.
Hello everybody, and thank you for attending this presentation of the Virtual Flow Forum. We'd also like to thank Oliver for giving us the opportunity to introduce the upcoming MCERTS Compact level sensors for flow. As Oliver said, my name is Peter Devine. I'm the technical manager at Vega Controls in the UK. And my colleague Matt Wesgate is our business development manager for water. Okay, so we are very mindful that there's a great depth of knowledge within the virtual flow forum in the field of open channel flow and event duration monitoring. However, we'd like to sort of start with some basics for those that are not so well acquainted with levels of flow. So the sensors we're discussing will fall under the EA MCERTS Performance Standard Part 3, which is for water flow meters, now in version 4 that came out in March 2020. And we're also mindful, as discussed by Andy Godley this morning, we're mindful of Part 5, the Performance Standard for event duration monitors. Obviously, as a manufacturer, we're very interested in how the performance testing for Part 3 water flow meters is transferable to Part 5 event duration monitors. So if we look at the MCERTS flow application into Part 3, applications, as some of you will be aware, is in effluent discharge monitoring, intermediate and continuous, but also instantaneous flow rates for applications such as flow to full treatment. Clearly, this is a very well-established standard, and obviously this morning the discussions were regarding Part 5, the draft for event duration monitoring. We're looking, or we're going to be discussing the Type A, as described by Andy this morning, basically an EDM that incorporates a water level sensor that provides direct or inferred level measurement of the water level up to and beyond the overflow level. So we're talking about a continuous level transmitter. Now, perhaps if we just take a step back, what do we have currently? What is the standard when it comes to MCERTS for level-based flow meters? Well, generally, we're starting with a generic controller housing, and these housings will come with some form of display. It might be simple flow rate, totalization, or it could be more sophisticated. So there could be color or monochrome displays. There could be a bar graph for flow rate. But the controller itself is the device that carries out the flow calculations. So the mineralization curve is done at this point. Controllers will then have some form of interface and keyboard for setup and interrogation of the parameters and values. And possibly there will be some relays for alarms, totalization, etc. So this is the standard, if you like. I've shown a sort of generic picture of what a controller will currently have when it comes down to flow measurement in open channel flows. Clearly, this is powered, mains or DC supply, and that controller in itself will then power some form of sensor. So the sensor very often is going to be, for example, an ultrasonic transducer, if you like, a dumb transducer, for want of a word, but it could also be a smart instrument. It could be a level transmitter, possibly ultrasonic or radar. So the controller, as said, provides the sensor power supply, and there may also be a case of a temperature sensor. So to improve, if you like, accuracy, the accuracy class within MCERTS, an ultrasonic sensor may come with a temperature. So again, there are different options available when you look at the CSA website. In the case of radar, there is not a requirement for an additional temperature sensor because the microwave signal is not affected by changes in air temperature from day to night, etc. So that's the basics, if you like. And then from that point, the controller, whichever one's selected, will have some form of comms out. And you know, there were some discussions about that this morning about the communications protocols from that point. If you take a look at the CSA website, currently there are 10 certificates for this type of device, where effectively there is a controller and a sensor of some description, and the linearization, as I said before, is carried out inside the controller. Moving on, we talked of, in the title, we talked about compact. So let's define exactly what we mean by compact MCERTS level-based flow meters. So here we have a photograph of a sensor, and to some people that may look like a very basic transducer that needs to be connected to a controller to provide the flow calculations. In actual fact, it is a smart radar transmitter with full capability to provide 32-point flow rate linearization, and that's all computed inside that sensor. It also has the heart diagnostics that were mentioned by colleagues earlier, and the Namor NE107 diagnostics, including, for example, measurement reliability. So that information can be picked up at some stage in the future if required. As well as flow, clearly it can be used for accurate level measurement. And the important thing, it is compact. So that everything is contained within the device. And I'll show you a bit later on how it's configured and how easy it is to configure this type of device for either open channel flow measurement or for overspill, pure level measurement applications. So when we look at the compact sensors, there are a range of them going through MCERTS, let's say pending, and with these devices they have Bluetooth communication, so they can be set up via a PC, a phone, or a tablet using an app. So that, again, simple communication. As I say, we will look at that now. So let's take a look and see what we get. So these are pure screenshots taken from a tablet. So we have connected, we've made the connection to the instrument via Bluetooth. I've given it a composite tag number, EDM-flow 01, showing you that in actual fact it can be used in an array of applications. And then when we connect, there is an application-based setup. So as you move your way through the setup, the first thing it asks you is, what is the application? So you can see there's a range of applications there, from stormwater, overflow, but I've selected in this particular case flow measurement across a flume or a weir. As we click on from that, the graphical support gives you an image of the application that you are selecting, and in the background, the radar, the smart radar transmitter, is optimized for that. For example, open water is going to potentially have different echo signatures than something that is perhaps underground, for example. So automatically, that is done in the background. The next thing is the min-max adjustments. All the measurements are made from the sensor reference plane, and the sensor reference plane is the face of the instrument itself. So the datum, if you like, I think with most sensors, is from the face of the sensor. Then we come on to linearization, and within the app or within the software, there is a linearization assistant, and it leads you through that setup. So you click on the blue writing here, Open Linearization Assistant, and at this point you could then select, for example, flow measurement, and under flow measurement you have a number of options. Possibly the most important one there is dimensions of ISO standards. So inside there you have the ISO standard calculations for open channel devices. If we click on that, it then opens up rectangular flume, trapezoidal flume, etc. V-notch weir, thin plate rectangular weir. Just for today, I've selected thin plate rectangular weir. And as we continue through, again, it gives us a graphical representation of the min-max adjustment. And then it invites you to input pertinent dimensions. And there you can see that we've completed the dimensions of this particular primary device. And clicking through, it then asks us to select the engineering units that we want to have displayed and retransmitted. So in this case, cubic meters per second. The setup assistant summarizes, I think, for you at the end, so you can see its flow, the scaling engineering units, the scaling format, and it shows you the maximum flow rate at 100%. And then finally, let's say, just give you a summary and writes all the information to the sensor itself. So here you can see we're still in the setup app, and you can see below the green 34%, we've got on the left-hand side filling height and the right-hand side scale values. Okay, so that's the setup, and it really, you're leading through blow by blow, and you need to get to the end of the setup assistant, and then it clarifies so that you can write the data to the device. So we come out and we look at one of the examples. This is one of the units with the display. On the display itself, you have a bar graph representation of the min-max adjustment. You have the tag number that we talked about earlier, and we have the value and the engineering units displayed on the sensor. Within the range, you may have seen, we also have the devices without the display. So in this particular case, using the app, we can use the app to display the values, not just setup. So you can see on the right-hand side there on an iPhone, we have the filling height in millimeters and the scale value in meters cubed per second. Now, it uses Bluetooth communication. One thing we should address is that Bluetooth communication is secured with a 6-digit PIN for pairing. It uses a challenge response procedure with a cryptographic hash algorithm. That's SHA-256 and a random number generator. So that the actual communication is secure, but on top of that, there's an additional possibility within the sensor and the app or the software to have an additional PIN to lock adjustment to prevent any unauthorized or unintentional changes during the setup. The instruments also have hazardous area certification. So, for example, the ones with the housing have a Zone 0 intrinsically safe certification, but the compact units with the cable have both intrinsically safe and also EXN, an encapsulated option. So Zone 1 with no barriers. So again, that giving you a bit more flexibility in the type of application and and the devices to which you're connecting, the power supplies that are available. So we're talking about flow rate or level directly from the sensor, giving us flexibility on this type of non-contact radar device. So essentially, we can linearize it for flow, or we can purely have it for filling height. And from that point, we can connect to basically anything. So we have the flexibility to connect to battery-powered data loggers, remote telemetry units, directly to SCADA systems, or we can do, as has been done previously, we can connect directly to a controller to provide a totalization function. As I say, the name of the game is flexibility, and I'm just going to pass over to Matthew.
Thank you very much, Peter. I've taken control, so hopefully technology works. You might be wondering why there is a picture of a penknife on the screen. Basically, penknives, versatile, robust, useful tools that can help us solve a lot of different issues or challenges that we might come across in life. Really, that's a theme that's been running through this presentation and what Peter's been talking about. We're talking about robust but versatile compact radar sensors. Quite interestingly, some of the discussions with Detectronic, Dave, Walker, and also from Brian from StormHarvester, we're talking about clean data. Brian sort of said better data gives better machine learning. I think it's really interesting because what we're trying to talk about here is giving cleaner data, more reliable data from sensors that were born out of applications that were really quite demanding. So what I really want to talk about during this session is some of the instrumentation that we've put out to the field, where we've been trying to cover over 2 different application areas, the versatility. So obviously, Oliver, right at the beginning of this workshop this morning, talked about the right sensor in the right place with the right installation. And I couldn't agree more, really. I mean, reliable and accurate level readings and level-based flow readings. We have to answer a lot of questions before we just apply an instrument, especially as the need for data increases, guidelines for the sensors and the installations evolves. We need to look at where do we actually need to make that measurement? Is it EDM spill point or an open channel flow measurement? Where physically in the location within the flume or within the site can we actually make that measurement? And how can we install the sensor? What fixing points are available? What structures are available? How are you going to power it? Are we going to hardwire it? Are we going to battery power it? Once you do power it, how are you going to collect the data from it? Where's it going to go? Is it going to be on an internal system? Is it going to go out into the cloud? So obviously there's a lot of different questions. And obviously, as we start to answer some of those questions, that leads us to the best sensor, the best technology that's going to be most suitable for that measurement. But also those answers help us to understand changes within the market and changes with regards to the demands from the market. And that allows the suppliers of instrumentation, in this case, to respond to that. I think that as the need for data evolves, so must the technology that's so vital in providing that measurement. So without any further ado, I'm going to dive on to a couple of applications. So the first one is some work with a company that we're doing that's providing a complete EDM solution to one of the major key UK water companies. This is a photograph of one of the installations. Our involvement really was to provide a level instrument that was capable of meeting the current and future EDM sensor and installation guidelines. What they did with our sensor here is they took one of the smart radar heads that had an ATEX approval, and they powered it with a completely standalone battery-powered telemetry system that they'd been working with a third party to provide. So as part of this project, they started the installations earlier this year. Currently, spoke to them a week ago, ahead of schedule. Everything's going really well, and well on the way to the first 100 systems being installed and operational as part of the EDM UMON3 scheme. The company that we're working with in this project and from this photograph have asked, due to some of their mechanical design and software design work they've been doing, they've been asked to remain anonymous during this presentation, but please do get in contact with me if you have got questions or want to be put in contact with them. With regards to the radar sensor that was selected, the reasons were it was future proofing. It was a 2 mil accuracy. I know Andy Godley mentioned 5 mil this morning, but 2 mil accuracy, easy setup using the Bluetooth app, low power consumption with this being a battery powered system, easy to deploy in a lot of different places, less than 12-second startup for the radar. And obviously with the impending MCERTS, so non-contact system, no maintenance. And I think as others have identified before, by putting in a type A sensor, we can get a lot of dry weather data as well. It's extremely useful and also proves the performance of the system rather than just it's switched or it hasn't switched. This isn't a concept design either. This is something that's being delivered on scale, and people are embracing this technology now with regards to how flexible it is. It doesn't have to be fed into a Vega controller. It can go into any controller that has an active 2-wire 4-to-20 input, any telemetry system with that same input. So it really does give ultimate flexibility with whoever's designing the system. Moving on to the second application. So I've got a couple of photographs here just to explain what it is that we're trying to talk about here. So this system, I think, gives ultimate amount of sort of choice and flexibility as a user out in the market. We're combining EDM UMON3 level measurements with an open channel flow measurement all into one neat MCERTS system. So the photographs here are from a customer site, but we're looking to do some performance testing to prove the system that's going through the MCERTS. And this won't be the site, but this is the kind of thing that we're looking at doing. So on the left-hand side, that's your spill point over a double-sided weir into the storm tanks, looking up against the flow. If you then turned 180 degrees, you'd then be looking down the flow towards the works, and at the bottom there you might be able to see it. That's where the flume is for the open channel flow measurement. Next photo just shows looking on the right hand side is just, hopefully it's going to catch up. That's just looking across the double-sided weir into the storm tanks. So what we're talking about here is ultimate control when it comes to choosing the instrumentation. On the left-hand side, if you were looking at doing your EDM UMON3 spill point, you could put in a compact radar that either does or doesn't have a display. Andy mentioned this morning that as part of the product standards, 5.1.3, the MCERTS inspector or environment agency officer would need to have a visual display of the discharge status. And so obviously we're able to do that with these sensors, either using the display or using the Bluetooth side of it. On the right-hand side, again, you can mix and match. You could use a compact radar sensor for your open channel flow measurement, and that can all feed into one controller, a dual channel controller with up to 3 current outputs for relaying information into telemetry, multiple totalizers. They can come with digital resets within them. In addition to that, you can have an 8 gigabyte SD card that comes with the instrument, and the capacity within that, if you're recording every minute, you can have 6 months worth of data. So a huge amount of capacity within these controllers. Certainly if you're deploying, there was questions earlier whether if you had poor network coverage, you would without doubt be able to back up any missed data by logging it in this device as your backup. As Peter mentioned earlier, intrinsically safe or explosion proof, these controllers can come with barriers like a lot of different controllers, so you can power any instruments that are out in the field with an intrinsically safe power supply. As I said, these are just a couple of different examples of where the instrumentation can be applied out in the field, whether it's a completely standalone system that's feeding into a battery-powered telemetry system, or if it's going to be a hardwired system with visual displays and totalizers, etc. Depending on the application, what we're trying to make people aware of, there is sensors that are now extremely affordable, that are compact, and they give maximum amount of flexibility in how they can be installed and how you can streamline instrumentation that's being used on site. I think from myself and Peter, obviously we'd like to thank everyone for listening. Thanks, Oliver, for inviting us to present, and we welcome any questions that you might have.
So, any questions? And from me to Andy or the regulators in the call, is that what the sort of thing you're envisaging for UMON 3?
Yeah, I mean, from our point of view, in terms of compiling the documents that we've got at the moment, very much so. It's very neat solutions, and it's a nice piece of kit. I think it's really useful, and it does show that the technology is available to do some really good quality monitoring for some of these applications.
And Mr. Chappell, you have your hand up.
Hello, Oliver. Yes, it's Andrew Chappell here from the Environment Agency. I was interested about the display options for this thing, particularly when you started talking about Bluetooth and the fact it had a 6-digit security code. Now, one of the requirements we have in self-monitoring of flow scheme, and I understand, as Andy mentioned this morning, is likely to be in the EDM scheme, is a need for our Environment Agency officers to be able to see the status and be able to see the flow measurement when they visit a site. Now, a 6-digit code is brilliant for security, but does that mean that if an environment officer who's not been on site before will have to jump through 10 forms of hoops and get codes from somebody else to be able to see the data? Will there be a way of just making the display and the actual measurement values easily accessible? Because that could be a problem in the future if it's not.
So that's I guess that's a two-part question. There are instruments with displays on them. With respect to the ones that don't have displays on them, we have the Bluetooth connectivity. From your point of view, is accessing it via a tablet from the user, is that an acceptable way of doing it?
If it's easy, yes.
Yeah.
It's about making it easy to do. Remember, we're a government body. We may not always have the latest, greatest, fastest kit available. Yeah. So it needs to be readily acceptable and not require this week's version of an iPhone.
No, I understand. So if the user has connected using a device, whether it's an iPad or an iPhone or an Android device, then it will have been paired so that handshaking and security has already been done. So if they can give you access, effectively, they will open up the app. They will have a list of sensors that they have paired with. You will say, I'm interested in that one with that particular tag number. They can connect to it and they can display it, as I showed you on one of the slides, where it was showing, for example, filling height and flow rate, which I think.
Okay. So it would require having a user or an operator to be with you who's got a paired device. Could you turn up with a non-paired device and access the data? Because our officers may go onto a site with nobody from the water company there.
It is, yeah. Okay, that's an interesting question. I suppose the question there is whether or not that they provide you with the information to make that connection.
Okay, it may be something you may want to ponder on into the future. If the information is not available to our officers and too difficult, then that may not be an acceptable installation against the MCERT standards. But I have a feeling that there's a lot of evolution to come in that respect in the technology. I'm sure it's capable of being considered. In terms of the display on the instrument, if an instrument's suspended over the middle of a channel, it's not exactly easy to see unless you've got a periscope.
I was just going to add in with regards to the PIN number. Yeah, you can have a PIN number that allows you to connect to it, and that's obviously part of the security side of it. If there is an installation where a local display is required, then we showed the compact yellow device that has a display built into it. So you would have obviously full access to be able to see what the level is. Just to sort of add into the PIN numbers, there is a PIN number that's used for connecting to the device that's supplied with the device at the time. You can then lock down the parameter changes with a further 6-digit PIN number. So just where we're talking about sort of connecting to instruments and maybe inspectors or officers going to site and connecting to them, you would also be able to connect and see data if you have the right PIN number, but not be able to make changes, which I think is quite a nice feature with regards to that security.
Oh, that's sensible, yes. I suspect this is it'll probably take a few years for us to get used to remote connectivity and technology. But I think it's something that as manufacturers yourselves, you will need to consider. That there could be some AN random environment officer who needs those numbers. They may not have the PIN number. There may be you may need to think of some way of accessing the instrument without compromising the cybersecurity and the instrument settings.
The ultimate, I suppose, Andy, is that you can put a display in the loop, a slave type display in the loop that will pick up the heart data from the instrument. If that was that is another possibility. But I think, as you say, thinking about what you said, finding a way of giving you access makes sense.
Thank you. Yes. Yeah. In terms of Oliver's generic question, like Andy said, I think this looks like a really interesting piece of kit, which I have every confidence when I've seen your stuff before. It looks like just the sort of thing we're hoping for.
Thank you.
Thank you, Andrew.
Any more questions?
Yeah, I'm just sorry, it's Darren Meaning from Siemens.
Hi, Darren.
And I'm just kind of trying to support Matt here, I suppose, a little bit. And I think, as Andy said, things are still evolving in this space. But if I look at some of the message in there from Matt's slide, it's a very similar message that Siemens as a manufacturer would go to. Let's look to future-proof future designs. And, as I say, this is still an evolving picture. But if we're using technology, like this, then, which has got the inbuilt accuracy, got in the smarts that we talked about earlier, the intelligence, and then it makes it far easier to do a future upgrade. If the Environment Agency decide that it does need a display adjacent to the transmitter, it's not a big expense. If you have to put in a new transmitter and a new display, then it becomes a far greater cost. So, as Matt was saying, I think the idea that we start to think about instead of waiting for guidance, try to preempt what that guidance might be.
Thanks, Darren.
Thanks, Darren.
Well, thank you, Matt. Thank you, Pete, for a fascinating talk. I've just had one last comment just to add from our experience. We find that if an EA officer is in a position to gain access to our sites, then they would also be in a position to have the correct codes, etc., to access any data needed, which is an interesting point.
Our second speaker of the afternoon is Rob Stevens of RS Hydro. Rob's going to talk about the Lee Tunnel Flow Measurement Project, which is an MCERTS application with absolutely vast flows. This poses great challenges to the industry of how do you MCERTS that sort of approach. So I'll let Rob take it away to show you how it's done.
Thanks for coming. Hopefully this presentation is as good as all the prevailing ones. It's been great so far today. So thanks, Oliver, and thanks for having me along. Number of slides here. This is really about an application that we did earlier this year on the Lee Tunnel, which is part of the Thames Tideway project down in London. And this is just really a bit of an insight as to sort of the before, during, and after what we've done to provide accurate flow measurement. So just to give you a bit of an overview, I'll give you a little bit of background then sort of set out the challenge of what was ahead of us in terms of what we had to try and tackle. We had to do a trial to prove that our technology was potentially the right technology. A little bit of an explanation as to how it works, and then lots of pictures about how the install went, a little bit of the data, and potentially some viewpoints about what the implications are for this type of technology. And that will probably lead into some questions. So probably just quickly, just give you a bit of a background on myself. I'm one of those grey-haired old flow engineers, been around about 25 years. If my kids were in the room, they'd probably say I'll be fatter than myself. I'm actually slightly balding as well now. It's all those years out on the field. Don't do them so much these days, but we've seen all sorts of flow applications, and we do a lot of integration as well. But as you may or may not be aware, RS Hydro, they started in 97. We represent a number of main suppliers into the UK, so the likes of Teledyne ISCO, Panametrics. We're a Siemens distributor as well, and so we're not only able to sell off the shelf solutions, but we actually integrate and install them. I'll show you a little bit more about that later on. So, okay, so a bit about the background firstly. The Thames Tideway project. It came in made of three big tranches of work. First of which is to create this super sewer, as it's known in London, who try and divert around about, I think it's something like 40 million tons of sewage going into the Thames each year. And that is to be then processed down at, hopefully my mouse, if you can see my mouse, you can see all the wastewater treatment works, and Beckton being obviously one of the biggest ones there. We have the Thames Tideway Tunnel, which is basically this, as you can see here, with obviously a number of connection points. So you're gravitating all the way down to here, and then it all ends up at Abbey Mills, and then it's all forwarded onto Beckton. We actually, there is another project here for the lead tunnel. This was the second project to be done. Sorry, my daughter's just started playing a drum kit. Great. So you got the lead tunnel here. It was about 7 kilometres long. That's what I'll talk to you about in a minute. And then obviously the third tranche of work was to build the actual Thames Tideway tunnel itself. Okay. The lead tunnel itself, it's a marvel of engineering. I think its lowest point, I think the excavations went down to about 100 metres below ground. Tunnel itself, as you can tell by the picture of the guy in the picture, is huge. It's 8.6 metres in diameter, and it's to divert about 16 million tonnes of sewage each year. Sorry, bear with me a second. I'm just going to have to shut the door. Okay, and ultimately they needed to be able to attain an accurate form of flow measurement for this wastewater being forwarded on. So the challenge, there are multiple challenges with this. This is just not your average small flow that you can engineer a very simple solution to potentially. There is a whole range of challenges that we had to tackle, and you can see by the list here. First of all, there are 5 barrels at the point that we have to measure. They're typically egg-shaped, about 2.7 meters in diameter, ATEX environment, and each one of those tunnels copes with up to about 6 tons a second of sewage. So that's a heck of a lot of water. Currently, prior to this project, there were 3 wetted sensors. They were obviously primarily for measurement, but also for redundancy. But inevitably, unfortunately, and it is a case of when, not if, the sensors started failing and they need a replacement. But these sensors, they need maintenance. Okay. And in order to do so, they had to drain each tunnel, to be able to do so, which is quite a feat in itself. So there's a load of isolations that have to be in place, and health and safety, and the cost and time element of doing that is quite immense. And they've been doing that routinely, doing 1 barrel a month, to be able to do that. If those sensors failed, okay, then you have downtime, and unfortunately for the it's not just a little flow that you can turn a tap off. It will take much longer, and plus you have to get everything else in line in terms of logistics, getting these sensors ordered and what have you installed. So that's a big issue. Health and safety. Well, this is obviously climbing up the ladder really for most water companies, in terms of being able to use sensors that minimize or eradicate risk. So that's another big issue, and reliability. Wetted sensors, we manufacture wetted sensors as well. They are unfortunately prone to ragging, whether it's by material or by silt. It's going to happen, and they will in time just stop working until they're maintained or cleaned. So a good, effective maintenance procedure is paramount. And then on top of all of that, these instruments have to be MCERTed. It was a requirement of the project. The trial itself. So there was actually 3 different technologies used for this. Now we haven't got access to the data. It's not probably fair for us to do so anyway, but there were effectively three different technologies. We've got on the left here, a conventional wetted area velocity flow meter. Okay. We have then a radar-based sensor that measures surface velocity, and then we have the laser flow. Okay. Which is subsurface velocity. You can see that both of these 2 options here are really basically class 3 MCERTS, whereas the laser flow is class 2. Okay. The trial itself lasted, well, originally it was planned for a month, but just for their own, it's just one of those things that happens in the water industry. Things do generally take a bit longer than you might hope. So the test actually went on for 3 months. We were logging continuously at 1-minute intervals. Thames Water were the only company that had access to all of the data. So, we had no idea what they thought of it until the end. But we did find out that the laser flow had met all the performance criteria, including being able to cope with the very high storm discharges, which is 6 QMEX in each barrel. No missing data. It was 100% reliable. There was no maintenance required. And ultimately, this had to have very high level of approval within Thames Water. And on that basis, we were given the green light. So I'll probably just step aside here a little bit now, just to explain how the laser flow works. So you can see a picture of a pair of them there for an MCERTS application, controlling an inlet to a treatment work. Laser flow itself has got a number of different sensors in it. So that's a side-on view there. It has an ultrasonic level sensor, which physically is this little grey bit here. Very conventional. If you took it apart, it would look like very many other industry standard ultrasonic sensors. Okay. And it has a laser, which is actually firing down this funnel here. Okay. The whole way it works, it's very similar to sort of the ultrasonic time of flight within water or air technique, except we're using laser. So I'm not sure how many meters per second. It's like millions of meters per second at the speed of light. But effectively, what we do is we focus a laser point beneath the surface. And to sort of animate that a little bit, firstly, what we do is we use the ultrasonic sensor to measure the level of the water. And then once we know the level of the water, we then focus the laser beneath the surface. Okay. And that is typically, we'll just say at this particular point, we take up to about 2,000 readings per second. And then we aggregate all of those readings into one reading at that spot. It's obviously, there's an awful lot of data there. And we can cope with a wide range of levels. We go up to around about 3.3 meters of depth. But the device itself doesn't actually measure all the way to the bottom. If you know hydraulic theory in water, what you're looking for is the peak velocity, which is really typically around about 0.9 of depth. Okay. So we're looking in and around that point. Once we know that peak velocity, then we know what the average velocity is likely to be. It is actually a very accurate technique. When they actually did all the R&D many years ago, they didn't see the point of having to go deeper. All that would mean is that they would have to use a higher grade laser, which would be more potentially of a health and safety issue. But they found by just doing these tests that it was more than accurate enough. And it has MCERTS class 2. So I think the writing's all there, really. The laser flow can work in multiple different ways. It can measure up to 15 different points. There are 2 different versions of the laser flow. There is a standard and there's a EX or an ATEX version. The standard version will do any or all of the 15 points. The ATEX will only do the middle vertical 3. These here. Okay. And that is really to get around the fact that one of the motors in there in the actual device was so that it would meet the ATEX ratings. So one of the sideways motors, servos, was dropped. Okay, but it measures multiple points, and then you can choose which point you want, and you can then get your flow measurement mark. In terms of the installation, okay, all of the 5 barrels were identical. They each had these 2 laser flows in place. Didn't really realize this, but you can actually see the bottom of the channel. It's part drained, and you can just see the actual sensor band for the wetted area velocity sensors, which were just being removed at the time that we put these in. But you can see the tunnel here, and you can actually see quite a lot of silt here as well. So it gives you an idea of the maintenance that's required for this. A little bit about how we work. We like to think we have a very unique way of working. We're extremely transparent, mainly because we have a belief in ourselves in terms of the way we work, that it's the right way to work. So the client has a login to our system to be able to see at what stage we've got up to, all testing documentation, all the drawings, documentation as we build it and put it all together. And basically, it's this big long process here, and it all ends up with a handover pack that we will give to the client. That handover pack cover is actually a living document, so it's actually a virtual document, so it's online. So once we've installed all of the instrumentation, that document doesn't finish. If we need to do visits, if we had to do a call-out visit, or if the client wanted to add something to it, they can add it to it. So at any point, they could just send a login to a particular user, say within Thames Water, and they could fire off the latest document to somebody. Includes all of this documentation. I won't go through all of it, but there's an awful lot there. The scope itself, so each tunnel had 2 laser flows. One was a duty, and one was a backup. Okay, and with 5 tunnels, that makes 10. They specifically asked for a separate display for each one, although you can feed multiple lasers into one transmitter, albeit not 10. They wanted it to be safe and easy to hot swap. So they didn't want to have the issues that they've had in the past, whereby they'd have to drain a tunnel, and they have to coordinate that in very dry weather, because otherwise they could get caught out. It has to pass MCERTS inspection, and what really changed it, made it turn it upside down a little bit, it was really the fact that all of this was the outbreak of COVID. So yeah, there was an awful lot of changes that were made in terms of health and safety and how we worked. So it was quite a challenge. That's two of the lasers there looking down. Chant flows going from left to right. And you can see here two handles. So there's one handle on this one and a handle on this one. They actually rotate by about 10, 15 degrees, and that will actually unlock the laser flow if you wanted to. And then you can actually just lift it to the surface. So if ever there was a problem, you can have what's called a street tool, which would basically have a little hook on the end or a gaff type of thing. And it would actually pull the laser flow to the surface. If you wanted to swap it or do any maintenance, you can do that all in there without having to go into the chamber. There is also a safety chain on it. So that was obviously just in case some freak event came along and battered it all to pieces or tried to. That chain was there as well, but you could also use that as a lanyard to pull it up. And the way that we had to install them is that we did 1 barrel per day, and we would leave 1 day in between the actual barrel installations to just as contingency to allow for a recharge, make sure the instruments were okay, there were no issues, and then we'd move on to the next barrel. So what we needed now, it was 1 camouflage kiosk. I think that's great because it's, you probably don't want a nice shiny kiosk in the middle of London, but I don't think anyone's going to think there's anything significant in that. And then inside that, we had 10 transmitters with all of that on real-time telemetry, obviously, for control purposes. A little bit about data. This just gives you an insight, really. Just come quickly. These two here, one is actually the level, one is actually the distance to water. This is 1 minute data, and you can see how clean it is. And each one of these little humps here is when a pump station is discharging. Okay, so it's going on and off. It's really good data, and that particular channel is pretty typical. It was doing about 2 to 2.5 QMAX. There's lots of diagnostic data. There's probably about another 20 other parameters as well. But we was talking about signal quality on ultrasonics earlier. Well, that is basically signal quality for the ultrasonic. So we can see that's in this sort of this about 80% mark, which is fine, but it's quite a turbulent flow, so that's fine. And this grey line here is a signal for the Doppler itself. Okay. All of these can be outputted via Modbus and Ethernet and various other different ways. A little bit about what this means. I mean, the laser flow has been around for about 5 or 6 years. And I think everywhere it's gone, it's completely changed the approach, the operation and maintenance of that flow meter. Obviously, it's sort of a holy grail statement that we can all go non-contact. There are obviously drawbacks and potentially with some devices with accuracy and whatnot. But nonetheless, we're all moving towards this lower maintenance regime, or hoping that we are. And at the same time, higher accuracies. So we like to think that this project is sort of really shown that ability to be able to do that. And in terms of the wider view, it's not to be forgotten that no flow meter is fit and forget. It can never be said, but it should have an appropriate level of maintenance and control over how it's looked after. But that does obviously, the less maintenance you have to do, the less you have in risks in terms of health and safety. So that's a big thing as well. It does underline the importance of non-contacts for other applications. Flow treatment is obviously a big one in the next term. We've proven it with MCERTS already. Unfortunately, the water companies aren't going to be able to magically find new channels or put a nice section of straight piped channel and to put a nice flume or whatnot. It's just unfortunately the focus is moving towards retro fit devices. Good data is an asset, not a cost. I see this more and more these days. We've done an awful lot of work in the oil and gas industry, and its cost is less of an issue. Obviously, oil is a high price commodity, but it's all about good solutions. Okay, cost is, and I know because of the system or what we're trying to measure isn't necessarily of high value, but levels of good data being an asset is definitely making its way through the water industry, and ultimately only good decisions are made on good data. Bad decisions obviously are not. And I always put this one at the end. A flow measurement system is only as good as the engineer who installs it. Unfortunately, there does seem to be less and less, really good engineers. I don't think we're educating enough. Comes out, it would be nice to see some more, but never undervalue a pretty good engineer. And I think that's it. So if anyone's got any questions, fire at me now.
Rob, there's only one engineer to come to in the industry.
Yeah, that's right.
Thank you for the heads up, of course. That's a hell of a way to end. There's only one engineer to come to, really. So, any questions? Darren, you've got your hand up.
Yeah, Rob, really interesting presentation. Thanks for that. And some very impressive statistics there. So I'm just curious, you said about the MCERTS certification on the lead tunnel there. I think you said 8.6 meters or something like that in diameter. From most MCERTS certifications sort of stop at around 3 meter mark. So how did you achieve an MCERTS certification on a pipe which probably has never been tested before?
Yeah, the one thing to state is that the actual tunnel is 8.6. There's basically 5 barrels, which by the Abbey Mills pump station, and that's the point at where we measure. So the flow is basically equally divided into those 4 barrels. But nonetheless, they're I think they're about 2.2 meters wide and 2.7 meters high. And it's a really good question. And the truthful answer is the M certification hasn't happened yet. But I suspect the situation because what's happened is that the site, I think, is just getting handed over now. So I think that's probably happening as we talk. But because of COVID, I think there's been all sorts of delays with all sorts of things. So I suspect that the certification will be happening very shortly. But it does remain, the question is, how do you MCERT a 2 meter wide channel, which you can't really get access to? I think that thereby more or less is my answer. It is tricky. There is no doubt. And unfortunately, it would rely, well, I wouldn't say unfortunately, it would rely on suitably experienced MCERTS inspectors, for sure, or thinking outside the box. So, situations like this, and we've all familiar with that and whatnot. You might have to try and do some sort of balancing test with meters that you know of. I mean, this is such a unique application that we probably won't get another one like this for quite some time. It's pretty hard to decide how you're going to get a certification on this, but nonetheless, it's going to be thinking out the box for sure.
I think, as you pointed out, there's always going to be these really exceptional applications that are going to be far more challenging and don't really quite fit into the MCERTS box. And the other thing, just quickly, then, is obviously in open channel flows, sometimes our biggest enemy is grit, siltation in the bottom of the channel rather than the meter itself or the accuracy of the meter itself. Is there any intelligence in your device to identify that?
Short answer is no. But I'm smiling because it's. I'm sure all of us smiling. You can see his face now. There are, I guess, there's two different groups of people here. Those that believe that you should clear the silt out, and then those that say, no, leave it there and let it stabilize. Okay. And I've had these discussions with, and it's right down the middle in terms of the MCERTS inspectors as well. And the reality is, in some respects, it depends which measurement approach you're taking. Okay. So if you're taking a flume, you've got to clean it. You've got to clean that flume out. If you're using wetted area velocity, you've got to clean it out. Okay. If you're using non-contact, you could arguably say, well, leave it, let it stabilize. It's not as if the grit's just going to keep going up, 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 and up, and up, and up, because you're going to get a certain amount of scouring that's going to be happening anyway in certain storm events. But I've got no magical answer to that. The way we deal with it is that we put in an offset. But the great thing about the non-contact is that we don't get affected by it. And in this application, the silt is not such a big issue because it's an egg-shaped channel. We've allowed for 100 mil in the bottom. By volume, it's not actually an awful lot because you're just taking the bottom part of the arch out. If you're a wetted sensor and you're buried by 100 millimeters of soil, well, it's just not going to work. It'll stop at around about 30 or 40.
And what I'd say on this, Rob, is yes, considering the application, I think 100 mil of silt's being generous. And that's probably because it's an egg-shaped sewer. But you're talking, 2.5 meters per second?
Velocity they're typically around about a meter per second.
Even at a meter per second, you're not going to get much grit in the bottom. But again, it comes down to the point that we all say all the time, it depends upon the application. It was interesting on the last presentation by Matt and Pete. They put the penknife up because most people who've had long discussions with me about flow is it depends. The laser flow, the non-contact AV, submerged AV, ultrasonics, radars, electromags, all of the flow meter technologies are very useful. And they are a technology within the armory for the various MCERTS managers in the industry. It's why when I was doing MCERTS within a water company, I worked with most of the suppliers in the industry. Why I stood up at an event and said, I've not got any money, I've got 694 test sites. And true to be told, the supply chain, I spent probably 10 to 15% of my time with the supply chain on sites testing equipment. And that was all to provide me as an MCERTS manager with the the technology for the right application. And truth be told, Rob, you were there and a lot of other suppliers were there. And I think together we got the instrumentation to a good place. So it's why the analogy of the Swiss Army knife is brilliant, because really the technologies that are available within the industry are all another weapon, probably isn't the right way, is all another technology within the toolbox to help get the right application. Lead tunnel, 100% agree. Non-contact AV, best way to go. Another application, it's going to be submerged AV. Another application, it's going to be electromag. Of course it is. But
Yeah,
that's...
I agree. Bottom line is...
Yeah. That
is this one here.
That fits into...
You can't undervalue this part.
Yeah, and as I'd agree, there aren't that many of us left anymore, really. So, yeah. But before
the reason for asking the question was because it's one of those things I've been again looking at some of the intelligence-based systems that we're looking at, and you know, and going, I suppose, back to Brian Moloney's presentation, where you could see, you know, when he was looking at blockages within the sewer network, you could see there was, you know, and over dry weather flow, you could see that gradually you were seeing a build up in the trend. And, you know, so one of the ideas I'm thinking of is that could we then sort of see a similar trend potentially, you know, in an open channel or flume situation, or albeit maybe not as much, but again, just identifying that there's need for maintenance, or taking your point, Rob, maybe not, just let you know, it equalize out. But, you know, potentially, you know, if those small changes could be identified, then we could, again, come away from sort of time-based you know, frequency maintenance regimes to something which is more intelligence-based.
Yeah, I agree.
Our last speaker of this year's Flow Forum is Martin Hardwidge of Katronic, who's going to talk to us about an interesting case study of using time of flight flow monitoring for RAS and SAS flow meters using Profibus in a old and difficult and hard to access application. So take it away, Martin.
Good afternoon, everybody. I'm Martin Hardwidge. I'm the Global Sales Manager of Katronic Technologies. I'll start with a small confession, actually. Although I don't think I've ever missed a WWEM exhibition, this is actually my first Flow Forum. So I'd like to say how much I've enjoyed it. I think the presentations have been extremely interesting, and there have been some very thoughtful contributions from other people. So thank you, Oliver, for putting this together. I hope that I'm able to see a few more.
My pleasure, Martin, and they started in 2014.
Did they? Shows you what I've missed, yeah. I was usually the guy got left on the exhibition stand. So. Anyway, today we're going to present a short case study looking at the use of clamp-on, non-invasive flow meters to measure activated sludge in some very vintage pipelines and delivering the data to the site SCADA of the system via Profibus PA. All I'm allowed to say about the sewage treatment works concerned is that it's somewhere in England. I'll be presenting the information, and my colleague, who you may all know, Matt Bird, will be on hand to answer your questions afterwards. Given that he makes Danny Dyer sound like a Yorkshireman, I think we might work out which end of the country we're talking about here. We're also delighted to be able to reference our friends at ABB and ZTech in the presentation. So I'll just skip past this. A little bit about Katronic. We were established back in 1996, and we're specialists. All we make is clamp-on flow meters, which we sell all over the world. They're used in all sorts of applications: oil and gas, pharmaceuticals, chemicals, food, applications that usually have the same thing in common, that it's either impossible or not cost-effective to break into a pipe. In those applications, a clamp-on flow meter, you can install it in a relatively short period. It offers significant advantages over other flow meter types, especially in a situation like this where we're installing 16 flow meters at the same time. I'm going to assume at this stage that most people who are listening are familiar with the measurement technique. So I won't go into that except to say that it involves clamping either one or two pairs of compact ultrasonic transducers to the outside of the pipe and calculating a flow rate by comparing the time an ultrasonic pulse takes to travel across the pipe in a downstream direction with the time it takes to travel across the pipe in an upstream direction. So if you need more information about the measurement approach, please contact us afterwards. You'll also see we have two other logos sitting above the line on the top of each slide. In the UK, we supply flow meters to the water wastewater industries through our friends at ABB and ZTech. ABB, as you know, leading flow meter suppliers, framework agreement holders with many of the UK's major water companies. And we also work closely with ZTech, process control and instrumentation installation experts, and our approved installation and commissioning partners. So let's start by looking at the situation on site. There were 16 lines of RAS and SAS. The site dates back to 1935 when the majority of the plant was installed, with a major refurbishment and additions made in 1959. The RAS and SAS lines are all grey cast iron, ranging in size from as little as 80 millimetres all the way up to 790 millimetres outside diameter. So in a nutshell, we have an old set of pipes, many of which have had 85 years and all of which have had more than 60 years to get a buildup of sludge on the inside and to get rusted and pitted. They've also no doubt had many a brick and lump of concrete running through them over the period. They're also, in the most part, running through old brick and concrete tunnels that are liable to flooding, but more of that later. The project was carried out in two phases. Phase 1, ZTech were commissioned to undertake a 24-hour flow survey across the 16 RAS and SAS pipes, both to see the range of flow rates across the range of the pipes and also to prove the effectiveness of the clamp-on approach. Katronic supplied portable flow meters via ABB for installation for the trial. Based on the results of phase 1, the second phase involved a further installation of 16 fixed Katronic flow meters, in this case CatFlow 150 models, with either single or dual path transducer pairs. They were subsequently retrofitted with Profibus PA outputs, and everything was installed by ZTech after being supplied as part of the framework. Okay, moving on to the phase 1 flow studies. I think you can see from the pictures the conditions the flow meters were installed in, and you probably get an idea of just how hard it would have been to install anything more invasive into these lines. The shadows go back for quite a long way into those tunnels. The initial flow survey was actually done in two parts. The first part was 6 RAS and SAS lines in a combined outlet. So we supplied a combination of models. The CatFlow 200 is a portable handheld device. CatFlow 210 is a long battery life survey device, really, and a dual channel CatFlow 230. Truthfully, the combination of units was partly because we didn't have that many identical systems available in our hire fleet, but in fact it doesn't matter. We almost always use portable units to prove applications because every flow meter in the Katronic range shares a common user interface and a common performance standard. So a successful test with one of our portable units guarantees a successful installation with any one of our fixed systems. The initial survey was followed up with a second test to pick up the remaining pipes, all of which were measured over a 24-hour survey period on battery power, with support from Katronic throughout. Data was logged with a flow measurement every 15 seconds. I just want to take a moment to describe what you're seeing on the screen of the CatFlow 200 on the left here, on the right here, the left of the two pictures. The two black lines along the bottom are important parts of our commissioning sequence. The top one represents signal strength. The further across to the right it is, the better. The bottom line represents signal confidence and is effectively a proportion of the top bar. So here, despite 85 years of sludge buildup and pitting, we've got great signal strength and perfect signal confidence. There are many more diagnostic tools to help us fine-tune the application, but this is the main indication of success. Here's one I made earlier. This isn't from this application, it's just to give you an idea. I hope you can see directly below the bottom line, you can see my cursor there, 3 small vertical markers, and in between the two lines, what probably looks like a little circle to you, it's actually a diamond-shaped cursor. And this is the positioning assistant. Once you enter the application details at setup, the flow meter will tell you how far apart the transducer should be positioned on the pipe. And then you can use the positioning assistant to fine-tune that position. The little marker will move closer and further away from the center line, depending on the signal strength. There's also a sound assist, so you don't actually have to be able to see the screen to tweak the transducer position. So over the period of the two tests, measurements were recorded on both the individual lines and the combined outlets. And then ZTech were able to show that the combined measurement provided a good match to the total recorded through the single lines. They presented that data to the water company, who then approved phase 2 of the project, which was the installation of the fixed flow meters. So again, through ABB and ZTech, we supplied 16 CatFlow 150 transmitters, all with compact K1L transducers. Depending on the diameter of the pipes, we chose either single or two-path measurement, so either one or two pairs of transducers wired to each CatFlow 150. The choice of two-path measurement is largely down to the likely consistency of flow within the pipe, which is typically related to the pipe diameter. If we believe that the flow may be disturbed within the pipe, then a two-path approach lets the flow meter calculate the flow rate more accurately and more repeatably than a single path would do. In this installation, we chose to double path all the measurements in pipes over 300 millimeters diameter. The actual installation presented some interesting issues. As I mentioned way back on slide 3, the tunnels can be flooded. So the transmitters were positioned a couple of floors above their position, a typical cable run of between 50 and 80 meters. It didn't help that the installation was done on the hottest couple of days of the year, meaning the installers were working at around 40 degrees centigrade. Matt Bird and Steve French from ZTech got through 24 bottles of water between them, most of which they managed to pour out of their hard hats later in the form of sweat. The actual temperature of the pipes was a much more manageable 18 to 20 degrees. So, given the age and condition of the pipes, it was really important that the transducers were perfectly positioned. The first part of that was to get the best possible connection to the pipe, for which we used our stainless steel mounting rails. The steel rails are very stable, and they're made specifically to fit the K1L transducers. Using the rails means that the transducers can also be really tightly fixed to the pipe and won't shift. The rails also make it easy to remove and accurately refix the transducers if they ever need to be adjusted. We use a coupling gel to get air out from between the transducer face and the pipe, and the gel also fills in any pitting present in the surface of the pipe. We could equally well just use solid coupling pads, though we've found that the gel maximizes the signal strength. You can see the transducer there in between the rails, so it's really quite a compact transducer there, and there's room for that to be adjusted along the ends of the rails without actually then having to remove it entirely, the fixing here a slide. You may remember a little while ago, I mentioned that the transmitters were mounted a couple of floors and a 50 to 80 meter cable run away from the transducers. Also that the temperature on the pipes is about 40 degrees, and you can see Steve in the background gleaming gently. The last thing the team on site would want would be to have to run backwards and forwards up and down the stairs to tweak the transducer position. So we offer a thing called the Katronic commissioning module, and you can see that just there in the little grey box there. So the idea is that that allows you to connect the transducers into the commissioning module and then plug that into a portable flow meter. In this case, it's a handheld CatFlow 200. And remember I mentioned that all the Katronic flow meters share a common ultrasonic platform and commissioning protocol. Well, that's important here because it means that we can do exact transducer positioning down at the pipe without Matt and Steve having to run a marathon backwards and forwards between the pipes and the transmitters. And that in itself significantly reduces commissioning time. In this case, all 16 systems were commissioned over 2 days, and that's days that were shortened anyway because of the extreme conditions. So after the commissioning module was used to set up transducer spacing, the positioning was checked on the CatFlow 150s upstairs. So this is one of the units 2 floors above. So you can see here that the signal strength and the confidence bars are all the way across, as we want to see. And the positioning assistant here has this little cursor right in the middle of the 2 bars, exactly where we want to see it. So it's a perfect installation. Initially, the system gave a 4 to 20 milliamp output, which was then replaced by a Profibus PA output into the site SCADA system. The CatFlow 150 is very flexible in terms of outputs, with milliamp frequency, open collector, relay, and various bus outputs available, including Profinet, simply achieved by adding up to 11 output cards in any combination. The actual card install was just a 2-minute job for each unit. Matt went to site again to support ZTech on that. The Profibus PA cards were then connected through P&F couplers to the site standard Profibus system. And you can see here 6 of the CatFlow 150 units on the walls, and these 2 green boxes of the P&F couplers. And then there's the site HMI system, HMI, which was also installed by ZTech. So to recap, and this is quite short, the initial flow survey was completed using a range of Katronic portable flow meters, proving that both it was possible to achieve a reliable measurement on these 85-year-old sludge pipes using clamp-on technology, and that the measurement was achieved matched the total flow through the system. Based on the success of that survey, a full installation of 16 fixed flow meters followed afterwards, equipment again supplied via ABB and installed by ZTech. Katronic supported on site. We used stainless steel rails and a Katronic commissioning module to help us mount the transducers on the pipes accurately and quickly. Finally, the 4 to 20 milliamp output that was initially supplied was swapped out for a Profibus PA module that matched the site standard. So thank you for listening. I'm now going to bring in my glamorous assistant, Mr. Matt Bird, to answer any of your questions. Thank you very much.
So is there any questions? I think it just goes to show what can be done when companies work together. And it's a great case of a very different application. I must admit, I remember Mr. French to do the initial that one. Mr. Chappell, you put your hand up.
Yes, Martin and Matt, I've got to ask a question. While you were talking, I was looking through the MCERTS list of certified products. I didn't see Katronic on the list. Is it something you would consider? Is it a market which you would it help you? Is it a market you're interested in, or is there some other sort of limitations or reasons why you've not gone through the product certification?
I think the best I can say at that point to that is very much watch this space. It's not something we've done before. It is something. Okay, I'll go public and say it's something we're actively considering and actively working towards at the moment.
Well, that's good to know. Any feedback or help you need, then I'm sure I'd put money on the fact that Mr. Godley is involved, and I'm happy to help out if need be.
That's very kind of you. Thank you.
Okay. I must admit, over the years, I've seen. I think flow monitoring technologies also do like clothes go in fashion, and the time of flight technologies have almost been dominated by the Panametrics, which is got to be at least a couple of decades old now as a technology. And there are some great time of flight technologies out there and got some great uses. But they're not really technologies that time of flight isn't a technology we see a lot of, and yet I think it could provide a huge benefit.
I think you're right, Oliver. It's
from the water companies. Is there any reason why time of flights aren't used as much in the wastewater environment?
Oliver, it's Andrew here again. Oh, sorry.
Sorry. I'll just say, Marcus, not really, as far as I'm aware. We've got a few Panametrics kicking about, which are obviously MCERTed, and they tend to be fine. In the main, though, we're using Siemens and ABB still, but there's no particular reason why we wouldn't consider that in the future.
Yeah, I mean, when I look at the asset base, one water company exclusively has open channel and electromags. A lot of the others have gone into AVs. I remember when I was at Anglin, we had perhaps 3 or 4, but that was about it. And I mean, I'm as guilty as anyone. I just don't know. I don't know if time of flights went out of fashion slightly, or Andy, have you got any opinion on it?
No, I think time of flight. When we've done the sort of audits on MCERTS applications, we've come across time of flight devices. I think from the experience, my personal experience with using them, particularly on wastewater treatment applications, is the uncertainties around potential for fouling inside the pipe and how you allow for that. So if you've got a pipe that you know stays clean, it's got a high velocity, it's vertical maybe, then it's a good technology. But there's often a risk if you've got a pipe that's got low velocities or influent with high grease and fat content, that the fouling can push the uncertainty.
Yeah, I must admit, one of the ones I saw it was on was a largish works, a pumped vertical, and there we did actually clean the pipe out, and there was very little debris in there, so that does sort of track. Andrew, you had your hand up.
Yes, I just wanted to say, water companies are certainly one of the major parts of this market, but from MCERT's point of view, there's also quite a few industrial sites. Mm-hmm. And some of the places we've seen, particularly sort of cooling water pipes and power stations, clamp-on flow meters there would be a very useful technology. And if it was, and you may find there's potential market there if when you get certified.
Thank you. I mean, I just like to say in general, if following this, if anybody would like to connect with me on LinkedIn and continue these conversations, I'd be very, very happy to do so.
Darren, you were next.
Yeah, I was just going to sort of pick up on your statement there, Oliver, about things going in and out of fashion. And I think initially, I think when we saw the very early transit time or time of flight flow meters, they were a bit flaky, if I'm honest. And also there was some confusion with Doppler flow meters, which is a slightly different technology, and because they were both considered ultrasonic flow meters, they were sort of somewhat tarred with the same brush. And but I think certainly in my experience in recent years, we're seeing a lot of sales now going out the door for clamp-ons with them rising mains, pumping stations, and also when we had the Flow 4 program, again, those just installations where it was just impractical to break into the pipe. So I think it has it is coming back, if you like. I think the need is driving it, and with the certification measures and the FFT, as we were mentioning earlier. And of course, just to pick up on what Andrew said, the fouling of the pipe, the issue is the same for any flow meter, really. So you've got to maintain the pipe, doesn't matter, or the meter itself, doesn't matter, how, what the application is.
That's just to interrupt there, Darren. I think that feeds into the work that the Technical Flow Forum, which basically all the water companies working together did, which was looked at the risk-based approach to pipe fouling, and that has identified where it's not going to say whether a pipe is fouled or not, but it identifies a risk-based approach to, if it's a pumped final effluent, the chances of it fouling pretty much zero. If it's
Oliver. Matt Burdett. I'm with Darren. Hello, Darren. Been a few years. the changes particularly in the transit time is big due to predominantly, I mean, if you look at 20, 25 years ago, the technology, sensors are the same, but electronics was always the difference and the algorithms used. But it was also, there was the differences between Doppler and transit time weren't really pushed that much. And there are differences. Plus, I think if you find now that transit time technology has moved on a hell of a lot and can accomplish a lot what Doppler can do. I mean, back 20 years ago, it was like wave a finger in the air, and that was it with a Doppler scenario if you were lucky. But now both have moved on significantly. And they're not the be-all and end-all, but there are advantages sometimes to using them, particularly in these old pipes. I mean, to be honest, can you get a crane down where we were? No. It wasn't very pleasant, as Mr. French and I spoke to you about many a time. And it was bloody hot as well. So it was about 45, by the way.
In the application you were particularly looking at, the transit, I would argue probably the only technology. I remember going down there and seeing a lot of DP flow meters.
Fisher and Porter.
Yeah. When we initially surveyed that site, getting a mag down there was impossible. Not going to happen. Absolutely not going to happen. So on that, I always say all these technologies are another tool in the box. But I don't see transit time being as used as potentially as much as it should be, and I don't know why. And I'll be honest, I don't know why it isn't used a bit more on those applications, because it naturally does have advantages. But anyway, Mark, you had your hand up. You've been very patient.
Well, I was just going to say, as a water company, we're massively interested in protecting our data and reporting accurate data. And so there's another consideration here, and that is the product. Providing it's an MCERTS product, if it has data storage, that would be a massive advantage. And most of the ones that we currently using, the Siemens 5100W converter head, the ABB Watermaster, and the old Magmasters, none of which have data storage. And if any one company had that, that would be a major plus point as far as I'm concerned.
Mark, ours has got a logger built in. It's cyclic, and at this site, what we did was put them on. I think it was about a minute. So with a variety of different diagnostics. So if there ever was a problem in the future, you can then just download it and look at it. So, but I think they're taking most of the data on their Profibus link. So,
sorry, what product was that? Sorry,
this is on the clamp-on. So we've got the loggers built into them. So it's logging. We're not just logging the flow, we're logging some signal noise ratios and things. So we know that if for instance, the pipe goes half full, so we're not getting a signal, you can then look back at it and work that. And that was one of the reasons why they do it. And pretty much I always put the logger on, even though you don't need to, because then you've got a record. Because some people don't have the data networks yet. So
it's all about protecting our data. And I know a company like Pulsar, where probably about 70% of our open channel flow meters, probably more than that actually. We use over the years, and talked to people like Alistair. They've developed their data storage. So going from a unit which had 9 days of total daily volume stored in it, we now have micro SD logging capabilities. That's a massive advantage for us, and really appreciated, because we just go to site some other time and know that we can get that data. It's going to be accurate data. We're going to get that back to the regulator, which is brilliant.
I think the other thing is, Mark, as we've discussed in the past, it's a case of approaching the supply. I did a few years ago with ABB. You mentioned the Watermaster there. And you know what I developed with ABB, and it's absolute collaboration. And it was that kiosk that made the installation very, very simple. And if you talk to the supply chain, and they're going to see it, and I know you have, then
Yeah,
there's
Darren,
always things that can be developed. I mean,
we do Ben here every couple of years at WEM, and the main question is, can we get some data logging?
Yeah.
So I think Darren's posted something on there which is interesting. So I'm gonna take a little bit more of a look at see what's out there. It's just a note really.
So
that it's a big consideration for us.
And the other way that I managed it is I put it in the framework agreement. It soon gets in there. So realistically, I think most companies now have got some sort of data logger on board, and it's just a case of when the new asset gets replaced, then that data logging capability will come in.
Yeah, I think generally it's being recognised that it's quite an important feature that we're after.
Yeah, absolutely. Any more comments, discussions? Anything else? I mean, Darren, yes. Yeah, Sean, just to pick up on your point with cloud and solutions, it's normally when the data for some reason fails, or it can be a site. I mean, I used to deal with sites which a mobile phone signal was impossible. I know Welsh Water have sites that you can't even get satellite into, and you can't get literally a satellite signal. So yes, it's there, but what happens when all comms fails, and you rely on local data logging? We'll also don't have data as the site with Profibus, yes, of course, but where you've got the small rural sites, there was one site I used to go to where you couldn't get a signal for 2 miles. Mark, did you put your hand back? Hand back up?
I do agree with what Sean says there in the comment, but realistically, where we're at the moment is a lot of these rural sites, they're just one single phone wire going up a pole somewhere and then off across a few farmers' fields, and problems are going to happen with that. So that's when we rely on the data recovery, however it might be. But realistically, it's travelling to sites and picking up the data or installing a logger, which is an additional cost.
Yeah, definitely. So, any more? Any more questions for any of our presenters so far today? I think we've stunned everyone into silence. So thank you very much, Martin. Thank you very much, Matt. Mr. Gilbert, Oliver, who will hold the budgets in the water companies, and will this come from CapEx or OpEx budgets? In what terms, Ian? So the budgets do tend to be split quite across the different water companies in terms of flow. And some of those budgets are restricted quite far down. I used to have a control over a budget, but then that used to have to be spent internally. I know other companies, the budget is very in the operational teams, and it's split between CapEx and OpEx. So a lot of my meter replacements were CapEx. A lot of all my MCERTS inspections were OpEx. So it does, and it's. I think the importance of flow has very much. Would it be fair to say to the water companies, the importance of flow hasn't really been realised as much as it should be yet? Still, I know it wasn't, and as MCERTS managers, all the MCERTS managers had struggled.
I think from my point of view, Oliver, from, as a water company, budget is the number one thing we come up against time and again. So, I would absolutely love to be one of these, early adopters of technology and trialing out new things and doing all of this great, because we can see the future is cloud-based technology and all of that. But again, we come up against, are our IT systems good enough? It's kind of, is it all going to fall over? So we've got to be really careful. And especially, at the end of last AMP, the purse strings were absolutely tighter than anything. And again, in this AMP, with Ofwat kind of slashing all of the water companies' budgets, giving us that challenge, we are looking at that, and we're coming up more and more where, our biggest budget and our biggest chance for exploring new technologies and big capital delivery projects are in the kind of, the WINEP, the UMON 3, the UMON 4, where we've been able to put that budget into, PR 19, or we will be putting it into PR 24, and that gives us a little bit of flexibility, and even that changes. So I think from the point of view of me as a water company, what I'd really like is to try and see some matching up of a lot of these standards and a lot of these new technologies, trying to link them in with our AMP funding cycle a little bit better, because I appreciate we're not your only customers and that sort of thing, but I think we'd have a lot more opportunity to explore and kind of see what's out there, and especially responding to changes in regulation and changes in standards and things. If that can be linked better into the AMP funding cycle, I think our accountants would certainly be a little happier. And also in terms of, finding new technologies and meeting new regulation a bit easier, I think certainly we would find that a lot easier, because our budgets are very, very small and can only really actively respond to a broken flow meter, not just look at improving what we have,
So a couple of points there. The thing I worry about is time as well, because I know most of the MCERTS managers are incredibly stretched on time, even more so when I was dealing with it. When I was dealing with it, I had a little bit of time to spend with the support chain, and I did. To say I was run off my feet was a little bit an understatement. I think somebody measured my usage at about 180%. I'm aware that you don't necessarily have the time. And then secondly, is that sort of investigation work something that could be done as a collective through, say, the technical flow forum?
So that would be something that would be, I would certainly be supportive of, in terms of, rather than, because I'm also probably need to apologise to a lot of the manufacturers on this call, because I do often get, emails or LinkedIn contacts and things from people, and I just don't have time to explore them or look into them. Whereas, if it was, we used the vehicle of something like, our water industry technical flow forum, that's then becomes a collective effort. And it's, okay, so I didn't have time, but Mark might have more time. And then later on, Mark might be busier, but I can then, maybe come up with something. Or, one of us can't use some of our sites to, test something, but someone else knows of a good site. And, I think it would be worth exploring that, I think.
It could be, and that can certainly facilitate. Ian, your hand was up. Mr. Gilbert? No. Mr. Godley, your hand was up.
Yeah, I just wanted to pick up on that point, because I sit on the Future Water Networks sort of planning sort of group that was organising our conference for next week. We had a long conversation about this, because though that's mainly clean water based, it does cover wastewater as well. And obviously Future Water Association is one of the trade associations for the supply chain. And that issue about sort of, everyone doing their own thing has been discussed time and time again. And there is an initiative, and James Hargreave at Anglian is really pushing hard on this, to do more, or come up with more robust processes and standards for collaborative testing across the industry, so that tests and trials done in Anglian water are acceptable to Thames and vice versa. So there is work going on around that sort of space to try and enhance that collaboration. To watch this space, I guess.
Jonathan, step in and say, because you made a point, are the right delivery vehicles being used? Possibly.
One of my feelings is the capital delivery route isn't the be all and end all, and I do really think that you can work collaboratively at an operational level to trial, not necessarily trial these products. There needs to be a need, otherwise there's not the need for the capex spend, as you know, Oliver. Maybe that's something we need to look at as a water industry.
Jonathan, that was exactly the way I did it. I just did it as a member of a water company. I spoke to the treatment managers and I put these units on trial. No real performance guidelines, but I think it was helpful for the supply chain as well, because they got to test and improve an instrument. And realistically, in the end, we ended up actually setting up a sort of testing site. Funny enough, through the minor capital route. And that was incredibly helpful and helped a lot of the non-contact AV. And what that also did was establish the relationships. So the operational route is absolutely a way to go.
And ultimately, Oliver, it solves a problem at the end of the day. Yeah, and that's mainly the key need or the key goal. But also, you're getting the benefits of trialing these technologies.
Well, it also meant for me, from an operational point of view, that the relationship was established. When I needed to speak to a supplier to say, I need a flow meter tomorrow, or I need a flow meter as soon as possible, I was really lucky with the supply chain, and they were always there for me. Okay. The clarification from Mr. Gilbert is microphone's not working properly. The reason I asked about the capex OpEx budgets was because if it was capex, then it would probably be delivered by the tier one contractors, who potentially won't be interested in what technology is out there and what benefits that brings to the water company. Yeah, absolutely. Absolutely. Okay, from Kathy, one caveat with the direct to ops route is that we're obliged by the MCERTS standard to include the MCERTS responsible person on big flow changes. Yes. Yeah, when I did it, I was the MCERTS responsible person. So, and what I was doing was quite informal, but empowered and helped me quite a bit. Darren, did you have a point?
Yeah, I was just going to sort of pick up on what Kathy was saying there, really. I mean, it's one of these kind of chicken and egg situations, isn't it? I just find that, as a business, I personally, trawled through PI19, looking at what the penalty payments are, what the potential payments would be through PI19 if, the cost of doing nothing, if you like, from a water company's point of view. And you're sort of, you're kind of given us the feedback, well, actually, that's not a very good business case. The fact that we might get penalty payments at the end of the year isn't a good business case. You're kind of thinking, well, what is? You're not talking small amounts of money here. This is hundreds of thousands of pounds potentially, and so I just kind of throw it a little bit back to the water company, saying, what do we need to do to prove the value of a solution? Because if saving hundreds of thousands, if not millions of pounds over the course of an ad period isn't a good business case, then what is? And also, I just going to sort of again make the point, if we're waiting for guidance from, be it the EA or whoever, that really stifles innovation, in my opinion. You end up waiting quite a long time to get the guidance, and you also find yourself in a situation where that guidance is kind of waiting for the industry to sort of catch up, if you like, because you don't want to see to put a single supplier forward who's got the only solution. So, the industry is in a position right now where PR19 is saying that you should be acting immediately, and yet we're still waiting for some of the guidance and indeed, some of the specifications to be finalised. And I think that, the time to act is probably sooner. But as I said before, give yourself, future-proof yourself in terms of what you put in. You don't necessarily have to put in a complete solution, but give yourself opportunities to advance that technology or that solution later, if you without having to rip the whole thing out and start again. So, that's my 2 pence worth for the evening.
Yeah, I think part of the problem is things are being delivered now, and they are going in right now. There are some great solutions. There are some solutions that I would say probably aren't necessarily going in the right direction out there.
Because they're being driven by cost, Oliver. It's what's cheapest and do the job now, rather than being, driven by, what is the industry looking for in the future.
Yeah, agreed. And again, what other use can we get from that data? Brian, you put your hand up.
Thanks, Oliver. Yeah, just to pick up on that point, I think it's worth us just mentioning again that from the supplier side, we really found that the Wesgate marketplace worked really well. And to pick up on Catherine's point, I understand that water utilities probably feel sometimes bombarded by sort of innovation and companies coming to them, but we'd much prefer to be told where to go and to be told what the need is at that particular point in time. And the Wessex Forum worked well for that, because there was a call, there was a specific time they wanted to know about it. There was a window to apply, and then they did an appraisal of all technologies that could. And that was driven directly from people within the business saying, this is the problem. Is there any solutions out there for this? They searched the market. They couldn't find directly any solutions. They saw some innovative products in an area, and then they ran competition essentially live on the network to trial some of these technologies live on the network. So I think from a supplier point of view, we don't really want to be bombarding utilities, because that's a lot of our time wasted doing that as well. So if the utility companies can point us in the right direction as to, okay, this is the forum that we accept innovation through, these are the callings, or this is the period of time, or this is the topic that we're interested in. And if it's a matter of waiting 6 months or a year, there's no problem waiting, because you'll waste a lot more time if you're just, if we're sort of cold calling utilities. That's no good for anybody, because they don't want it and we don't want to be doing it. That's just my 2 cents on that, Oliver.
There are forums, and to be honest, I think the Wessex marketplace has been particularly successful. There are forums out there, because so UU have their innovation lab, Northumbrian have their innovation festival, Anglian Water also, because I was part of it when I was there, had their innovation route. I think some work more successfully than others, and the Wessex one obviously worked particularly well. But I also think, I think the innovation strategy that came out 2 or 3 months ago, and the final version came out about 3 weeks ago, is brilliant, because it does give that direction. But also there's that need to show the art of the possible as well, because a call to market for one particular solution may not cover everything. So I suppose that's the art of, that's where these forums come in, and and the thought leadership across the industry comes in. It's demonstrating the art of the possible. So funnily enough, when I was speaking to you, Brian, pointed out what you were basically doing, which is absolutely fantastic. I think I wrote an article in 2014. So it's great to see that realised. It's nice to see it happen, but I think that there's that interplay as well that really needs to happen as well. And this is probably going out in the scope of this flow forum, but the water companies have always been known to be difficult to break into. And I've had a succession of, over the years, heard, we don't want to hear about any more widgets. So how do you, I suppose it's how do you separate the wheat from the chaff that makes it difficult, that's difficult, and on both sides. And some of that's direction, but it is a bit of a push and a pull in reality. Is there any more thoughts, discussions? In some ways, this is a forum, so if there's any ways that the water companies want to work together, is it the Technical Flow Forum? Is it for flow, for wastewater flow? Is it any other route? Certainly different aspects have worked for me over the years. But I think the flow is such an important thing right now, and it's becoming more and more important. That flow, why I organised today in the way I organised it was, yes, measurement's important. Yes, EDM, the EDM program, UMON 4 is important. UIM 2 is important. And I'll admit that UIM 2 is me. But so is the holistic, so is the solutions being discussed by Siemens and being discussed by StormHarvester. They're important solutions because they've got potential to help. And Siemens said, actually, we want active engagement to help. I honestly think there's an opportunity through the Innovation Fund for Siemens, StormHarvester, and the water companies to work together to produce that solution. And maybe it is a bit of both. There's no reason why it shouldn't be. Duncan, your hand is up.
Hi there. My point, Duncan Mercer, 7 Trent. I think new kit's good, but we need people to get it in the ground, and there aren't many sort of tier 1 or larger contractors involved in these discussions. So maybe that's another route to help get kit into the ground. I'm interested in kit, but I'm also interested in someone that can come to site, can put it on a bracket, can drill into our channels and get it out there. So potentially, yeah, thinking a bit more about the contractors that companies work with when they approach water companies is a good idea.
Duncan, you know where to come to. You know where to come to. There's only one place to come to. Yes, and I think there has been a bit of a drive in the past with getting the kit in the ground in the right way. I know some of the MCERTS inspectors have said that a new installation shouldn't be to 8%, it should be to 5%. And agreed. We've talked about the potential for approved MCERTS installers. It's contentious. but it's one way of handling things. And that's particularly MCERTS. Over the years, we've talked about today about data quality. Fitting the right instruments, yes, the right application, and keeping an eye out on the WIPAC group, because I will be talking about instrumentation and digital transformation at the beginning of December, and the instrumentation lifecycle at the beginning of December. And that's fitting the right instruments to give the right data, but it's also fitting it in the right way to enable operation and maintenance, because the number of sites that are okay for the origins of MCERTS, the number of mag meters that were buried and all had to be dug up in the end. And that still remains a problem with some of the water companies. But equally, the number of level sensors I've seen hanging on wires over tanks with the sensor in the middle of the tank, so that sensor's never going to get maintained. It's funny enough, it's coming up in the British standard for wastewater ICA. It's coming up in that the standard will be that it's operatable and maintainable. And installation wise, that's got to be more of a consideration. But we'll see the way that goes. Any more comments from anyone? So if no one's got any more, I'm going to say thank you all very much for coming. Thank you all to the 33 people who have hung on towards it. It's greatly appreciated. Keep your eyes out for the webinar next month, where I'll be talking about instrumentation and transformation. We've got a number of webinars planned over the next few months, so keep your eye out for that. I will be working with everyone at WEM, so keep your eye out. The WIPAC group will tell everyone what's going on with WEM, but I'll keep in touch with a lot of people on that. WEM's always been a great supporter of WIPAC, and it's greatly appreciated. And if anyone has any instrumentation problems, then please get in touch. Thank you all very much for coming, very much to all our speakers. I hope all our speakers will be uploading their presentations if they haven't already. And you have already uploaded yours. And Brian's already uploaded his. Thank you all, and keep in touch. Take care, everyone.
Okay. Bye. Thanks very much.
Thank you.
I do hope you've enjoyed this year's Flow Forum, and if you have, you'll come along next time, hopefully in person, but if not, because of the coronavirus pandemic, then maybe again virtually. If you've enjoyed this, then please join the Water Industry Process Automation Control Group, and please feel free to contact me through LinkedIn or via any other means, especially through Detectronic Control Systems if you need any help. My thanks must go to International Labmate, the organisers of Water, Wastewater Environmental Monitoring Conference and Exhibition, who have been very good to WIPAC over the years. And also to Detectronic Control Systems, my employer, who have supported me in bringing together the WIPAC Flow Forum. Thank you very much, and take care.